Hello! In this tutorial, we will recreate Stardew Valley in Godot. We are going to have farming with different plants, a fishing game, jobs that sell different hats and machines, and the machines actually do stuff. There's a day and night cycle, along with rain, we have basic combat and character interactions. To make this game, we will use a lot of advanced Godot features, like autotiling and animation trees, resources, tools, and shaders, and we are going to use Godot's hardware monitor to check the performance of the game. If you're stuck in basic Godot projects, then this course should help you to expand your scope and become more comfortable with more powerful tools and complex projects. For this YouTube video, we will cover all of the basics. The paid version has the machines and style upgrades, the fishing game, resource management, and the weather system. It is about twice as long as the free version, and you can get it on Udemy for about $10 to $20. You can also get it on my Patreon for £5, and if you subscribe there, you can get all of my courses for £5 a month. Subscribers also see new courses early, and you support me making more of these courses. So I hope you enjoy. And also, you can find the Start project in the linked Google Drive folder, along with the finished thing and some intermediary steps, just in case you get lost. Here we are in Godot, and you can see that we already have a couple of things. Most importantly, we have two scenes, a level and a player. The level at the moment doesn't really do very much. It's simply a couple of node 2Ds, and then somewhere in there, we have the player. The player is doing a bit more. We have a character body 2D, a sprite 2D, a collision shape, and then we have an animation bit. We have an animation player and an animation tree. The animation tree at the moment doesn't do anything, but the animation player, if you look at it, is doing a ton of stuff. We have a lot of animations that we need to manage, and for a lot of animations, we have a sprite 2D frame animation, and then we are also calling a function. This will become important later on, but for now, this one simply prints tool, nothing else. Which, by the way, is all we have inside of the player script. So not much is happening here yet, we just have to talk about the animation player and the animation tree. I'll do that later, don't worry too much about it for now. So this is all we have in terms of scenes and nodes inside of the entire project. Besides that, if you look at the file system, the actual game assets are inside of audio. This one is super simple, just a couple of audio files. And then we have graphics. This is a very, very chunky folder. For example, for the characters, we have all of the basic enemies or characters. And besides that, for the main character, we have a sprite sheet with all of the possible animations, which includes a lot of stuff. All of this we are going to control via an animation tree. But step by step. Besides these two folders, we have the scenes folder, in which at the moment we only have the player character inside of characters, and then we have inside of levels the level. Pretty simple. Then we have two empty folders for shader and resources. We'll add stuff to those later on. Besides that, there's a pre-made folder. There are a couple of steps in this tutorial where we have to do some work that is just labor intensive. It's not interesting, it's not challenging, it's just taking some time. And inside of this folder, I have a couple of presets that are going to make your life a bit easier. I'll talk about these parts when we get to it. Finally, we have a global folder in which we have two files, both of which are globals. If you look at project settings, and globals, we have enum and data. Inside of the code, besides the player, we have enums and data. Data is simply a whole bunch of dictionaries with a, ton of data. I'll go through all of this step by step when we need it. But fundamentally, we are just working with dictionaries. Inside of enums, we have all of the enums. Via those, we're categorizing the game. For example, for the player style, we have a basic style, a cowboy hat, an English hat, a baseball hat, and so on. If you don't know what enums are, don't worry too much about it, I will explain them. They're not that complicated. Now this is all we need for the basics of the game. I guess besides that, if you look at project and project settings inside of input map, I do have quite a few input actions. For example, for left, right, up, down, then we have an action. This is, for example, for the tool use. Then we have tool backwards, tool forwards, and a style toggle along with a seat forward. Via these actions, you can select different options, like for example the player style or the tool that we are using. Then we have a date change action, an action to build stuff, like a sprinkler or a scarecrow, and we have a diagnose button. This will show a screen with all of the plans and the current resources. Quite a few actions, and for all of those, we have key bindings for the keyboard and for a controller. And finally, if you look at General, under Window, I have set a custom window size of 1920 by 1080. If that is too large for your screen, you can set it to a smaller size. Like for example, 1280 by 720 would also be perfectly fine. Although in my case, I want to keep it at 1920 by 1080, which is the most common resolution. Besides that, if you go a bit further down, under 2D physics, we have a couple of collision layers for the terrain, the player, the objects, and the characters. Should make sense. And finally, if you look for texture and textures, I have set a default texture filter to nearest. Since we are working entirely with pixel art, we want to use nearest. That way the pixel art stays nice and crispy. If I use linear, let me demonstrate it really quickly, and we go to the player, it is going to look like a mess. You could fix that on a node-by-node basis by going to Sprite 2D and then texture, filter, nearest, much better. But this would be cumbersome, so I want, for the entire project, set a default texture filter to nearest, and then we always get nice pixel art. With that, we have the project set up. Oh, and I forgot, if I run the actual scene, we are getting the player character somewhere here inside of a large screen, and we can't do anything, which is totally fine. For the first part, I want to work on the basic player movement, which means for now, we can move and get a basic move animation. And for all of that, we are going to use an animation player and an animation tree. Even though all of this looks fairly simple, we do have to manage a lot of data. Let's actually have a look. Inside of the player, we have an animation player, which controls all of the animations. And you can see we have a lot. For all of these animations, what we are doing, fundamentally, if you look at graphics, characters, and main, there we have main basics. This is the graphic that we are currently displaying. Although, if I drag it into the editor, you can see that the actual graphic is a lot more complex. That is because for this Sprite 2D, for the basic player, inside of animation, we have 33 H frames and 4 V frames. This is all of this. We have 33 horizontal frames and 4 vertical ones. This entire thing is effectively a table that we are picking from. And for now, we want to work with these animations, where the first 2 frames are the idle animation, and then the last 4 are the walking frames. If the player is walking down, we want to play this animation, and if the player stops, then we want to play this animation. Same for left, right, up, and for all of this, we have the walking state and the idle state. To animate all of this, we already have the animation player. For example, when you look at idle down, you can click on the 2 frames. We have value 0 and value 1, which means we're getting this one and then this one. We are simply going between these 2, and all of this is being looped, so we are playing all of this continuously. If you then go to walk down here, we are getting frame 2, 3, 4, and 5. These 4 frames here that are going to be the walking animation, which is also looped. The same principle applies to all of these frames. I simply organize them by picking specific frames depending on the animation that we want. Let me get rid of this one, because now we have an issue. Inside of the animation player, we have a ton of animations, and we want to select the right one. For example, if the player is walking down, then we want to play the walk down animation, which looks like this. It's pretty basic. Now this we could do via GDScript, but you can see we have a lot of animations and managing all of this manually is going to be quite labor intensive. To get around that, Godot has an animation tree. The entire purpose of this thing is to manage an animation player. Especially when you have a lot of animations, this thing is incredibly useful. And that we are going to use in just a bit to animate the player. Although before we can get to that, we have to work on the basic movement of the player. Because at the moment, if I run the scene, I can press any button, nothing is going to happen. Also, the player is incredibly small. That we should fix right away. Inside of the player, I want to add a camera 2D, on which I want to set a zoom level of 4, and then we can see the player a lot better. Besides that, inside of the player script, I want to add a func move, in which we are getting a direction that we need for lots of other stuff. So as a global variable, I want to have var direction, which is always going to be a vector 2. And then inside of this move function, I want to override this direction and get input get vector, in which we are getting the 4 actions for the input: left, right, up, and down. All of these are defined inside of the input map: left, right, up, and down. The order here is also important. We need -x, negative y, and positive y. Once we have this direction, we can update the velocity of the player, which is an inbuilt property of a character body 2D. This will determine the movement, so this I want to set to direction and multiply it with a speed, which at the moment we don't have, so var speed with a value of 50. We have to call move and slide to apply the velocity. And for all of this to do something, we have to call it inside of physics process. So in there, move. If I now run the entire thing, I can press the input action buttons, but nothing is going to happen. That is because inside of the actual game, we don't really have a background. Or well, we do, but it's entirely gray. So the player has no context for movement. To fix that temporarily, I want to add the Godot logo somewhere here to the layers. That way it's in the background. And now I can try this again. And you can see the player is moving around. Definitely something. Also, for now, we don't need delta time. That way the debugger is happy. And we also have basic movement. That looks alright. With that, we can work on the actual animation, because right now we always play the down idle animation, the one that we are getting from the animation player by default. Idle down is set to autoplay. To customize all of that, we have to use the animation tree. Let's talk about this one. Fundamentally, the animation tree is simply controlling an animation player. And there are 3 ways to use it. Number 1 is a blend tree. This one lets you add complex logic to manage different animations. For example, you could blend together 2 animations, or you could play one animation continuously and then one-shot another animation, so you're only playing it once. Besides that, we have a state machine. This one also moves between different animations, but in a much simpler way. All we can do in there is to move from one animation to another animation. And that's pretty much it. Finally, we have a blend space. This can be in 1D and 2D. For both of those, we can select an animation depending on the position. For example, in our case, if the player is looking to the right, we want to pick the right walking animation. Blend space is ideal for that. And really important, you can combine these as well, which is what we are going to do. All 3 are important to make this system work. Back in Godot, first of all, to get started with the animation tree, let me add another one. I want to have a second animation tree. If you add this one by default, Godot is giving you a warning that we need a root animation node. You want to go to the inspector, and under tree root, you can add a couple of things. And those are the nodes I have just talked about. You have a blend tree, a blend space 1D or 2D, and a state machine. You can also add a basic animation or a basic root node, but those don't really do very much. You basically never use them. In our case, we want to start with a blend tree. In there, you get a basic workspace that we have already inside of the animation tree that was in the project. In the project, we also have a state machine. I'll talk about that in a second. First of all though, in AnimationTree 2, inside of this workspace, you can right click and then add stuff to it. But none of this is going to do anything because we have to connect this animation tree to the animation player. And for that, inside of the inspector, you have Anim player. In there, you want to drag and drop the animation player like so. And then you can use this animation tree to control this animation player. For example, I can add a basic animation, click on the symbol, and then we have all of the animations of the animation player. Like for example, let's say X right, and then you can connect the nodes to output, and we're getting the X right animation. That's how an animation tree works on a really basic level. With that, I want to delete animation tree 2 and work exclusively inside of the first animation tree. In there, the tree root is a blend tree and the anim player is the animation player. So what we have done before. Besides that, inside of the blend space, we have a state machine called tool state machine. If you open this one, you can see that we have something pretty complex. This is a state machine. In there, we are moving between different animations. For example, from the X animation, we can go to the hoe animation, the sword animation, the seed animation, the water animation, and the fish animation. And if you open any of those, by clicking on this button, you can see a blend space 2D, in which we are selecting different states of the animation depending on the position. If the player is looking to the right, we want to get X right, for example. Now, this does get very, very complex. So I want to go through it step by step by creating another state machine. For that, you want to right click and then create another state machine, which is what we need to do anyway, because we want to have a move state machine. This one is entirely for moving and idling. Or to be a bit more specific, for the animations for moving and idling. And this we want to connect to the output node, so whatever animation we are selecting in here will be played as the output. Next up then, if you click on Open Editor, you get this field, where we are starting in a position, and then at some point we are ending the animation. The way a state machine works is if you right click, you can add different things. The easiest one is Add Animation. In there, you can select whatever animation you want. For example, I want to have idle down. Then we have this animation. And now if you click on this Connect Nodes button, then you can connect start to idle down. If you're doing that, once the scene is ready, we are starting here and going directly to idle down. And you can also customize the transition. At the top, we have immediate sync at add end. This can also happen automatically or only when you run some code. And these two, by the way, you can also customize inside of the inspector. There we have the same options. And I guess just so that we have something different that you can see, I want to add a different animation besides idle down. Let's say seed left. To this animation, I want to transition right away. That means now, inside of this move state machine, we're going from start to seed left. And this is the animation that will be selected. After that, if we're going back to root, this state machine has seed left selected, and via this output, we are going to the actual output of the animation tree. So the animation that will be played is going to be seed left. If I run the game, we're getting the seed left animation. This one only plays once. I hope so far all of this makes sense, because we have to make it just a bit more complex. Inside of the move state machine, we don't always want to go to seed left, so let me delete it. Instead, we want to get all of the idle animations, so idle down, left, right, and up. And we want to get the walk animations, Walk down, walk left, walk right, and walk up. Adding all of these one by one would be way too much work. So for that, we have a blend space 2D. Let me add this one and rename it to walk. If you now click on this edit button, we're getting a blend space 2D. The way this one works is, if you right click, you can add an animation along with all of the other stuff. For example, on the right side, I want to add the animation for walk right. Once we have that, we can move this crosshair in the middle, and if this crosshair is exactly on this point, then this blend space 2D will select this animation, which will then be selected inside of the state machine, although we do have to connect it like so. Then we have the animation inside of the move state machine, and finally, inside of the blend space, from this state machine, we are going to the output. As a final result, we would be playing the walk right animation. It does get a bit complex when you're getting started, but once you understand the system, it makes a ton of sense. Let me add a few more points. Right now, we have the right animation. Besides that, all the way on the left, with the mouse selected, I want to add another animation for walk left. Then at the bottom, I want to add the animation for walk up. And this might be a bit confusing, but if you look on the left side, there we have the vertical range. We start at -1 and we end at +1, meaning this axis is inverted compared to the normal Godot game. Inside of the normal Godot coordinate system, -y is going up, but in this coordinate system, -y is going down. Basically, up is down and down is up. A bit confusing, but you do get used to it. Finally, at the top, we have to do the opposite, so we want to get walk down. Now we have 4 different states that we can select between using this crosshair. You can move it around manually, but that's not really what we want to do. Instead, if you have this animation tree selected, under parameters, we have a 2-state machine that we are going to work on later, but we also have created a move state machine in which we have walk, and there we have the blend position. This blend position is the position of this crosshair. If you set it to 0 and 0, you can see it's inside of the center. And if you move it around, inside of the inspector, you can see that we're getting different positions. By default, I do want it to be on position 0 and 0. It's really important to understand that we are only playing this animation, for example, if the crosshair is exactly on it. If the crosshair is only close to it, Godot is going to be confused. So you do want to be really careful here. And to be extra safe, what you can also do is add an animation in the center of this blend space. Just to demonstrate. In the center of this animation, I want to get fish up, something completely random so you can see what's happening. Now we have 5 different positions for this animation, and those we want to select using GD script. That we can do inside of the player script using a func animate, in which I want to check if we have a direction, so we know that we are moving, and if that is the case, I want to get the animation tree and then set a value. The value that I want to get is inside of parameters, and then you get all of the options you can target. In my case, I want to get parameters, move state machine, walk, and blend position. If you're not sure how to get this value, simply click on AnimationTree, hover over the blend position, and then Godot is giving you the path to it. And now we need a value for it. For now, let's simply say vector to dot right. And else, if we don't have a direction, I want to do the same thing, except we want to go back to vector to down. Make sure you're calling the animate function, and now I can run the entire thing. By default, we're getting a walk down animation. And if I go to the right or have any direction, we are playing the walk right animation. If I stop moving, we are going back to the walk down animation. If I comment out this animate, we are getting the default. So if I now run this, we're getting the fish up animation. For the walk right animation, when we have a direction, so when the player is moving, we're going to vector2.right, this point here. And when we do have a direction, we're going to vector2 down, which is this point up here. Remember, the vertical axis is inverted. So vector2 down would be a vector with 0 and 1. We are not moving on the x-axis, but on the y-axis, we're going to position 1, which is up here. Which means we are playing the walk down animation. And that is the basic system of an animation tree, where we, first of all, via blend space 2D, select the right direction for the animation. Then, inside of the move state machine, we're getting the right animation state. In just a bit, we will also add the idle animation in here. And then finally, inside of the blend space, we can combine this animation with other animations. For example, later on, this state machine is only going to be played once. This state machine for the movement will be played continuously, and the animations for the tools will only be played once. After it's done, we are returning to the state machine for the movement. First of all, though, we have to get all of the movement animations when we have a direction. That is going to be your exercise. I want you to create the walking animation logic, for which, inside of GDScript, I want you to select the right movement animation from the blend space 2D. If the player is moving to the left, then we should actually play the move left animation. If the player is moving down, we should get the move down animation, and so on. You want to expand this logic here to capture all of the directions. Pause the video now and see how far you get. And remember, inside of the blend space 2D, you have to be in the exact right position. You can't just be close to it. I want to uncomment this animate function, and now we can expand this logic here. First of all, the one thing that you have to be careful about is that we need to have exact positions for the blend position. What is really tempting here is to simply use the direction that we are getting from the player. This would kind of work. If I now move in only one direction, we are getting kind of the right animation. However, once I start moving in different directions, things fall apart pretty quickly. That is because inside of the blend space 2D, if the crosshair is not on any of these discrete points, the animation logic is going to fall apart. To get that, once we have a direction, I want to get a var direction animation, which is going to be a vector2, in which we're getting the direction, but we're going to round it. So direction x is going to be rounded, and the same we want to do for direction.y. That way, any float value we're getting inside of this direction is either going to be 0 or 1. And this value we want to use for the actual blend position. This is going to be much better, but it's still not perfect. If I now go left, right, up or down, we are getting the right animation, and this works pretty well. The problem is, if I go in two directions, let's say down and right, then the animation is falling apart quite badly. The reason for that is, once again, inside of the blend space, we do have these 4 points. But if we are going diagonally, we are in these corner points, and those we are currently not accounting for, which we can fix by simply adding a few more points. In the top right, I want to add walk right, and the same I also want to do in the bottom right. Walk right once again. I think the best way to think about it is that you always want to cover the entire available space. On the left side, I want to get add animation and walk left, this one here, and same in the bottom left, walk left. With that, we are getting all of the possible positions. And now I can try the whole thing again. I can walk in all directions, and we are playing the right kind of animation. This works. To finish up the basic movement, we need to expand the animation tree to toggle between animations. That way we have an idle animation and a tool animation. inside of Godot, in the animation tree, inside of the move state machine, at the moment, we are always automatically going to the walk state, which isn't correct. Also, inside of this walk state, the default animation shouldn't be fish up, it should be walk down. We should never be able to get to this point, but it's nice to have a safeguard. Anyway, besides the walk state, I also want to have another blend space 2D for the idle state. In there, we're going to do pretty much the same thing that we have done before. I want to add a whole bunch of animations. On the right, I want to have idle right, and this I want to do in the mid right, in the top right, and in the bottom right. Inside of the center, I want to have idle down, this one here. On the left side, I want to have idle left for all of them, like so and so. And then at the top, remember, the entire thing is inverted. So in here, we need idle down, and at the bottom, we need idle up. Now we get all of the directions, and inside of the state machine, I want to instead go directly to the idle state. The transition to the walk state, I want to delete for now. So we only have to worry about this idle state. Once we have that, inside of the script, we do have to make sure that we are updating it, because at the moment, we're going to the move state machine and then to walk. But this I want to do for idle. And now, if I am going around, we're getting the idle animation for all directions once I start moving. Which means now, we have to figure out how to move between the idle and the walk state. Now by default, I always want to go to the idle state. But then, I want to be able to travel between these two states. And that you do by simply connecting them. Although this animation should not be automatic. I do want to be able to travel between them, but it should be deliberately. It shouldn't be automatic. Add an arrow in both directions, meaning we can go from walk to idle and from idle to walk. And this is not automatic. These arrows should be gray. If they are green, the animation is going to happen automatically. After we have that, inside of GDScript, I want to have easy access to the move state machine because having these long paths is not really easy to work with. Instead, I want to have on ready var the move state machine, which we can get via the AnimationTree and get. Simply type move state machine, and you want to have parameters, move state machine, and playback. Playback is important here. That way, we are getting the move state machine, and there's one method that we need to use. Move state machine, inside of animate, if we have a direction. If we are moving, I want to travel to a specific state, which is the move state, or whatever you have written inside of these boxes. In fact, this is called walk, so let's fix it, walk. However, if we are not moving, so we don't have a direction, then I want to go back to the idle state. That's all we need to travel between these two different states. But before we can use that properly, we have to update the blend position for both of them, for idle and walk. This we don't have to do when we don't have a direction. So for now, I want to update the blend position for both of them, like so, with the same variable. And then we have pretty much the entire logic. Let me run it, and then I can explain. If I now walk around, I get the walk animation, and if I stop moving, we're getting the idle animation. If I go left and stop moving, we are also getting the idle left animation. This works on the right side, up, down, and also diagonally. This looks perfect. And just to explain it, when we have a direction, we want to walk, get the proper direction for the animation, and then update the blend position for the idle state and for the walk state. That way, once we stop moving, we retain the right direction. Basically, when the player is walking left and we are stopped moving, then we want to play the left idle animation. which we can only really set when we have a direction. If we don't have a direction, we don't really know in which way the player is looking. I hope that makes sense. This is kind of all we need inside of the animate function. Later on, for the tools, we are going to add a bit, but that's kind of it for the basic code that we need for the animations. And I hope you can appreciate that this is very, very little code. Most of the logic happens inside of the animation tree, and it's quite easy to understand, or at least I hope it is. Let's go through it one more time. The most important thing that we are working with is inside of the animation tree, we have a blend tree in which we can blend together different animations. Although at the moment, we only have a single one, the move state machine. Whatever output we're getting from there is connected to the output node of the animation tree, so this one gets played. Now, inside of this move state machine, we are automatically traveling to the blend space for idle. But we can also travel to the walk state and move between these two at will. Both of these are blend spaces 2D. If I open the walk state, then you can see we are selecting one animation depending on the direction. And this is just going to be a vector 2. Let me actually draw on it so you can see this a bit better. Fundamentally, all of this is just a coordinate system. The origin point is here. This would be position 0 and 0 for x and y. This point would be 0 and 1, while this point down here would be 0 and -1, whatever you're getting down here. On the right side, for this point, we have 1 and 0, and all the way on the left, we have -1 and 0. Each of those points has an animation attached to it, and this we are selecting by updating the cursor position. At the moment, it's in the origin point, but if we moved it up here, we would be selecting this top animation. Although this is not what I want to do. So inside of the animation tree inspector, under walk, this should be for the blend position 0 and 0. All of this we want to do via GDScript anyway, which happens in here. And that is pretty much all you need for the basics of an animation tree. I guess if you look at the root part for the blend space, in there you can add a lot more stuff. You can one-shot an animation, you can blend animations together, you can change the animation speed via time scale, and you can add other nodes to it. Especially for 3D animations, this kind of blend space will become incredibly important. But even for our purposes for this game, it's still very useful. In fact, let's use it right now. I want to connect the state machine with the move state machine. And once again, as a reminder, inside of tool state machine, we have the animations for all of the tools. I guess a better way to visualize that is if you look at the animation player. There we have the stuff we have already seen, the idle animations and the walk animations. Besides that, we have the X animations, the fish animations, the hoe animations, the seed throwing animations, the sword animations, and a bit further down, the watering animations. For each animation, we have one direction, and all of that is being managed inside of the state machine for the tools. And then for each state, we have the same setup that we have seen before. Which means when we are pressing a button, I want to play this animation once and then return to the move state machine. And for that, the node that you want to use via right-clicking is called one shot. It does exactly that. It plays one animation continuously, but also lets you one-shot an animation. So the animation plays once, and then you return to the original animation. In our case, I want to connect the move state machine to the in slot and the tool state machine to the shot part. Also, this should be tool one shot. All of this should be connected to output. As a consequence now, we are not going to get any kind of change. So this part hasn't done very much. That is because we have to tell this one-shot node to fire. If you click on this drop-down menu, we have fire, abort, and fade out. If I click on fire, we do get the animation. And if you want to stop it, click on abort, then we are back to the default. This we have to control via GD script, for which I want to add another function. I call this one func get basic input. Later on, we will have different kinds of input. But for now, all I want to check is if input is action just pressed with the action, the one that we have defined inside of the input map under action. On the keyboard, that's the spacebar, and on a controller, this would be the A button. If that one is triggered, I want to get the animation tree again, and then set another value. I want to get, number one, the tool one shot, and you want to go to parameters, tool one shot, and request. In there, you have to set a value. The data type that you want is going to be quite long. You need an animation node one shot dot one shot request fire. Quite a long one, but this is what we are going for. And fundamentally, that's all we need. If I now run the game again and I press space, nothing happens because this function is not being called. Before we are moving, I want to get basic input and try all of this again. I can run around, and if I press space, we are getting the watering can. That is doing something, but it's not amazing yet. Also, we are going in the wrong direction. To fix all of that, I want to work a bit more inside of Animate. Because at the moment, we are only updating the blend position for idle and walk. But now that we have the tools, we have to update all of those as well. If you look at this tool state machine, you can look at any of these. We have to update the position for every single one of these markers. Also for X, the start position should be in the center. Let me go to the inspector, AnimationTree. Under tool state machine for X, this should be 0 and 0. That should actually do something. If I now run the code again and I press space, we're getting the X animation. Inside of the tool state machine, we're going from start right to the X animation. And the default for this one is this one in the middle, where we are getting X down, which we didn't play before because the crosshair was vaguely here. So Godot didn't know what animation to pick. Be super careful here. If the crosshair isn't on a specific point, you are going to get weird results. Can be quite annoying. So once again, this should be 0 and 0. And now we have to make sure that we are updating all of these points. Now you could go through them one by one, like we have done here, where you would get the tool state machine and then something like X blend position. Would be possible, but we would end up with a lot of code, which would be very repetitive, so this is not what I want to do. Instead, when you look at data, we have tool state animations, in which we have an enum. This one doesn't matter for now, but this enum is connected to a string with the name of the animation that we want to update. Actually, this isn't the name of the animation, this is the name of the blend space 2D that we want to update. Effectively, we want to cycle through all of these values and use that to update the animation tree blend position. This is going to be an exercise for you. So to summarize, I want you to update all of the tool blend spaces. For that, use the tool state animations dictionary, and you can entirely ignore the enum keys. The only thing that you need are the values. Loop over them and use that to update all of the blend spaces. Pause the video now and see how far you get. I think the best way to get started is to duplicate this line and then update a single blend space 2D, for which we have to go to tool state machine and then update X blend position. This would be one of the animations that we want to target. And if we're doing that, I can run the entire thing again, go in a certain direction, press space, and we're getting the X once. Looks pretty good. The problem now is, if we went to a different animation, this wouldn't work anymore, because we are only updating the X blend position. To get all of the animations, we need a for loop. Or let's call it animation in data.toolStateAnimations. That way, we are getting this dictionary. On there, we have a key value pair where the key is an enum and the value is a string. The only thing that we care about is the string, which means we only want to get the values. If you're doing that, let me print the animation. You can see that we're going to get a lot of data with the strings of the values. This we want to use to update this line dynamically. And to be super clear here, we want to get a var animation name, which needs to be a string. The value is going to be all of this. Let me copy it. And the only thing that we have to change is this value, the name of the blend space. We want to break the string into two parts and then add a bit in the middle, which is going to be the animation, which in turn is one of these values. Once we have that, we can use the animation name instead of this path, and then we are done. If I now run the game again, the X is still going to work. And to test our tools, what we can do inside of the tool state machine, we can get rid of this connection and then start, let's say, on the O, and do make sure that this transition is automatic. If it is not, I can actually demonstrate. If I now press space, the animation is just going to break. Because we are stuck on this point, you want to get rid of this one and then create a new automatic animation. Then all of this should be working. Now we get a whole, works pretty well. And for the final attempt, we can go to the sort, get rid of this one, and create a new transition. That way, I can use a sort. That also works pretty well. Perfect. Now that we have the basic animations, we need a system to toggle between the different tools. This could be done in a number of ways, but I think the best one would be to use Enums, which is what we are going to focus on in this bit. But let's go through it step by step. Number one, for the tools, we have 6 in total. An axe, a hoe, a watering can, a sword, a fishing rod, and seeds. For all of these, we need to know the current state, and we need to be able to toggle between them. For all of that, to set the current tool, you could do something like this, where you have a current tool variable, and then you identify the current tool via a string, where we have watering can, axe, hoe, sword, and stuff like that. That would be possible, but it's also quite dangerous, because there are different ways of spelling that, and this could become quite confusing. Especially if we work on a larger project, and especially if you work in a team, this is a major consideration. It is really easy to forget the precise names of a state. The solution to all of that is Enums. These provide very clear state names inside of our Godot project. If you look at the code under Enums, we do have a ton of Enums. For the player style, the player state, so are we moving around, fishing, building, or shopping, the tools that we have, the machines that we can build, the seeds that we can use, the items that we can collect, and the kinds of shop that we want to work with. The Godot documentation actually has a pretty nice section on enums, which isn't very long because enums fundamentally are very, very simple. Basically, they are constants. That's really all they are. Constants where we only care about the name. And those usually you create inside of a dictionary. This dictionary can also get a name. That way, you can categorize the entire thing quite a bit easier. You might be confused here that, for example, for tile brick, we're getting a value of 1. So fundamentally, we are working with integer constants. But the point of an enum is that you don't really care about the value. What you care about is the name of this constant. So you know exactly what you're working with. And internally for Godot, it uses these values to understand what the state of the game is. In our case, for now, we only care about the enum for the player tools. The value for x would be integer 0, For hoe, we would get 1, sword would be 2, water would be 3, fish would be 4, and seed would be 5. Now these values are super important for Godot. It needs them to know what state we are on. But for our purposes, they basically don't matter. All that we see is tool.x or tool.hoe or tool.sort. And we always get a nice prediction with the name. And we cannot use any value that isn't inside of this dictionary. That way, it's basically impossible to have a typo. But fundamentally, when we are actually using it, inside of the player function, inside of getInput, I can print, for example, enum dot tool dot, I think the first one was x. If I simply print the value, we're getting the integer 0, which can be useful to know, but for our purposes, when we are using enums, we primarily look at the name of the enum. I think once we start using it, it's going to become much more obvious how the system works. In my case, first of all, I want to create a var current underscore tool. The data type for this one has to be enum tool. That way, we can only use a value from this dictionary. You could also assign a default value via enum.tool and then whichever you want to use. Let's go with sort for now. After we have that, we can work inside of getBasicInput, where we are checking for the action input. Before we are playing the actual animation, I want to travel inside of the tool state machine to the right animation, or rather to the right blend space 2D. This we have done already. Inside of animate, for the move state machine, we are traveled to the walk state or to the idle state. Now we want to do something fairly similar, for which, once again, I want to on ready var get the tool state machine, which we can get by copying this line. The only change that we have to make is instead of move, we want to have tool state machine. When we are getting the input inside of this if statement, I want to get the tool state machine and then travel to a certain state. And now we will need a target value, for which we need the names of all of these different blend spaces 2D. Now you could write in there, for example, x, and that would work. If I now run the game, we're getting the x. And if I write, let's see what the name was, for watering can, we have water. We are always going to get the right animation that works really well. But this is already dangerous because for the watering can, this could have been called watering can or watering underscore can, and you might get the spelling wrong as well. So if this W is uppercase or lowercase is also quite important. Simply using the string here isn't ideal, but inside of data, we have a dictionary where we have the enums with the proper name. If you had a team, this would be the dictionary that everybody consults for the proper name of the state, which we can use. I want to have data with the tool state animations and then use the current tool. And I think now the purpose of this system makes a lot more sense. Inside of our current tool, we can see that we have tool.sort, which we cannot misspell. If I try to write sort, for example, Godot is going to complain. This spelling of sort is not allowed. We have to write it like this. And then, inside of data, we have an enum with the exact same value that is then going to return something useful. So now, because we have this current tool, we should be getting the sort animation. And we do. If I change this to, for example, to water, then we are getting the watering animation, and this looks really nice. Also, if you simply write tool and then the dot, you get a preview of all the allowed values, which is really handy. And with that, we have enums. They are just a way to be really clear about the names of your variables. although we can push the system a lot more. Because at the moment, we can set a default tool, but we cannot change it inside of the game. But that we can do by adding another if statement. I want to check if input is action just pressed with tool forward. And I also want to check the same statement, except now tool backward. If either one of those two is triggered, then I want to change the tool either going backwards or going forwards. For which, first of all, we want to get the direction that these two values return, which we can get via input and get axes, where we need the negative and the positive direction, which in our case is simply going to be tool backward and tool forward. Let me print the result, then this is going to make a bit more sense. And by the way, inside of project settings, under the input map, tool backwards is Q on the keyboard or the shoulder button on a controller. For tool forward, it's the E key or the other shoulder button on the controller. If I now run the game and I press Q or E, nothing is happening. That is because this shouldn't be and, this should be or. Next attempt. Now, if I press E, we're getting 1 or -1. That way, we're checking for either of these inputs only once, and we're getting a direction from both of them. This we can use right away to update the current tool. And all we want to do is += direction. And to make things easier to explain, the default tool should be X, because this one has a value of 0. But let me go through it step by step. The variable current tool is tracking the enum, which is a fancy way of saying that we are only allowing integer values in here. At the moment, the value of X is 0, and if we add the direction to it, and let's say we are getting a 1 from that, then this value would return a 1. Godot is perfectly happy to update an enum like this. The only change that we really should be making is that this direction should be an integer. So wrap it in the int function, and then we're getting something. Although Godot is already complaining that we are supplying an integer when an enum is expected. But importantly here, this is just a warning. It's not an error. We can remove that in just a second, but for now, let me simply test it. If I run the game and I press space, we are getting the X. And if I now press E on the keyboard, we are getting the hoe, so the next tool. If I press E again, we're getting the sword. If I press E again, we're getting the watering can. And once again, if I press E, we're getting the fishing rod. And finally, we are getting the seeds. I can also go backwards by Q with the Q key. And now we are getting the earlier tools. This works really well, with a couple of exceptions. If I press E too many times, at some point, we're getting an error. We have set the value of the current tool so high that it is outside of this dictionary, which can happen quite easily, but that we can fix. For that, we can use modulus, where we are assigning a new value, which is going to be current tool, plus the direction inside of parentheses, and then mod with enum.tool.size. And just so you have an idea of what is happening, let me print the current tool. And before we can start, this direction needs to be an integer. If I now try all of this, I can press E, we're getting 1, 2, 3, 4, and 5. And if I continue pressing it, we're getting back to 0, 1, 2, 3, 4, and 5. This also works the other way, at least kind of, because in there, we're also getting the negative values, which we really do not want to have. But those we can get rid of by using a Godot function called posMod. That way, we are only getting the positive modulus values. This function wants to have two arguments. The first one is the actual value. So in our case, current tool plus the integer of direction. The second argument should be the maximum size, which we're getting from here. With that, I can press E as many times as I want. We are always toggling between the range of 0 and 5. If I press Q, when we are going below 0, we are starting at the end of the dictionary. So we go from 0 to 5. That works really well. That way, we can never go outside of this dictionary. Finally, to get rid of the warning, we just have to add enum.tool. Then Godot treats this value as an enum, and that is all we need. If I now run the entire thing again, if I press space, we're getting the X. If I press E, we're getting the whole. And if I press E a few more times, we're always getting a different tool. This also works with Q. We are getting different tools. I can press E as many times as I want. We are always getting a functioning game that doesn't crash. All of this we should practice. So let's do an exercise. I want you to track the current seed like the tool. Inside of the player script, I want you to add a variable for the current seed. And then from enums, make sure that the player can select one of these 4 seeds. This should look similar compared to what we have done down here. So use the enum values to give the player the ability to toggle between them. With one limitation, for the seeds, the player can only go in one direction from the input. Check the input map and see what actions you can use. For now, we are not really going to use that value, so simply print the result. Pause the video now and see how far you get. First of all, we don't need this print statement anymore for the tools, and on top of that, I want to create a var current underscore seed, where the data type is always going to be enum.seed. And I guess we also don't need the default value for the X. That just feels a bit cleaner. With that, from the enums, we can only pick from one of these values. With that, inside of getBasicInput, we want to check if input is action just pressed, and somewhere in there we have seed forward, which is the only action. There's no seed backward. Inside of the input map, seed forward is the C key on the keyboard or joypad button 1. Just pick the one that works for you. If that is the case, I want to update the current seed, and I have a typo in there. This should be a lowercase s, like so. This value I want to update like we have done up here, with the one exception that we don't need this direction. We simply want to increase the value of the current seed by 1, which means we want to have posmod with the current seed plus 1. The maximum size is going to be enum.seed.size. And finally, all of this should be senum.seed. And then you are done. If I now print the current seed and run the entire thing, I can press C, and I'm always getting another seed, and we are never exceeding the dictionary. That works really well. Before we are finishing up with this part, there's one more change I want to make. Inside of the game, I can run around and use a tool. But when using a tool, the player shouldn't be able to move around. That just looks a bit weird. To implement that mechanic, I want to have another variable called canMove, which is a boolean that by default is going to be true. After that, inside of physics process, I only want to do all of this if canMove. This at the moment is not going to do anything. We are checking if true, and then we are doing all of this. For the actual logic, when the animation of the tool is starting, I want to set canMove to false. And after the animation is done, I want to set it back to true. That we can do via the AnimationTree, because in there we have a whole bunch of signals. The two that we care about are animation finished and animation started. On top of that, it's really important to understand, once you have an animation player that is controlled by an animation tree, you cannot really use the signals inside of the animation player. So in there, we also have animation finished and animation started, but those wouldn't work reliably. The animation tree is simply overwriting most of that. So once you have both of those, you want to primarily work inside of the animation tree. In my case, I want to connect both of the signals. animation started, and animation finished. We are not going to need the animation name, at least for now, for either of them. All we want to do when the animation has started, I'm going to set can move to false, and once the animation is done, can move should be back to true. That's all we need. If I now use any kind of tool, while we are using the tool, the player cannot move. This works for all of the tools, and this looks pretty good. Feels significantly better. Later on, we have to refine this system a tiny bit for the fishing rod, but for now, that's all we need. At this point, we do have a basic player, but that is kind of it. So to make the entire thing much more interesting, we are going to create the level around the player. And for that, we are going to use a whole bunch of tile map layers, which are more or less the default way to create levels in a 2D scene. That being said, to make this process easier, we are going to use terrains, which lets us create levels dynamically. But step by step. Here we are back in Godot, and at the moment, our entire background is the Godot logo, which isn't ideal, so let's get rid of it. And I want to replace it with a tile map layer. Really important here, there's a tile map and a tile map layer. The tile map on its own is depreciated, so you shouldn't be using it anymore. I want to have a tile map layer that should be renamed to, let's call it the grass layer. You probably have seen something like this already. Inside of this tile map layer, you can create a tile set, so new tile set, and then inside of this tile set, you can add a graphic, which in our case, we can get from graphics. There we have tile sets, and somewhere in there, we have grass.png. Drag and drop this one in there. And we do want to create an atlas texture. An atlas texture, by the way, is just a texture that can be subdivided into individual cells. That's all it really is. In this particular case, the atlas texture covers all of this, and we have separated it into bits of 16 by 16 pixels, or whatever you have specified inside of the tile size of the tile set. Inside of the tile set tab, you can edit it. Inside of tile map, you can use it to draw inside of the level, like so, which in the game is already looking quite a bit better. And if you spend a ton of time on this, you can generate a really nice looking level. Let me create a couple of basic shapes, like this and this. Then we can go here. Then we can go here. And for the inner parts, we can just fill the entire thing, like so. These tiles all combined cover all possible combinations, so you could create pretty much any shape. The issue is that drawing them manually is taking forever, so simply creating this kind of shape means you have to individually pick all of these tiles and then draw them on one by one, which really isn't a fun process. But luckily, Godot lets you automate the entire process. This is done via terrain sets. In there, number one, you have to add an element where you can set a mode. You have match corners and sides, match corners and match sides. I'll explain how this works in just a second. But first of all, when you expand this terrain, you have to add another element, meaning you first create a terrain set and then a terrain inside of the set. In there, you can set a color, which will become relevant in just a second. You can also give it a name. Let's call this one grass. Once you have that, you can go to Tile Set, Paint, and then inside of Select Property Editor, you have Terrains. In there, you have the terrain set, and we have terrain set 0. That is the terrain that we have just created, in which we have another terrain, and there we can find grass. On top of that, we can change the color to reflect how this thing is going to look like. Inside of the tile set, you can select which tiles you want to use, which for me, for now, are only going to be these tiles here. The top left 4 on the X and the Y axis. Once you have those, you can tell Godot how these should connect. And let me zoom in just a bit. I think this part here is the easiest to explain. For Godot to automatically combine all of these tiles, you have to tell it how they should connect. For example, this tile here can only connect to the bottom one via this middle bit. Which means when we are drawing on the shapes, which you can do by simply left clicking. If you have a shape like this, where you only have the center and the middle bottom, then you tell Godot that this tile can only connect in this way. And when you then connect this bit like so, and this bit like so, then Godot knows that these tiles can only connect in this way. Once you have that, inside of the tile map, you can go to terrains, and there we have the grass terrain, which you can now use to paint, and we are getting one long line that only works in this direction. If I go anywhere else, Godot gets confused and doesn't really know what to do. But that's the basic principle. When you're looking just at this one line, all the way at the top, for this one tile, we are placing this bit here. After that, for all of the middle parts, we always have a part at the top and a part below. And since we told Godot that we have a part at the top and a part at the bottom, with nothing else connected, Godot is always going to pick this part here. And finally, at the end, for this part, we don't have a bottom connector, but we do have a top connection. So Godot picks this one. And that's kind of the idea of a terrain. You tell Godot how tiles should be connecting, and then Godot connects them for you automatically. Now, for this system to work properly, you have to add all of the connections, which does take a bit of time, but once you have it, it's incredibly helpful. And I guess just for now to get started, I want to add this shape, all of these shapes, and then all of this should be connected as well. Like so. And then we are getting a lot more shapes that we can work with. So once again, inside of tile map, terrains, and grass, if I now draw a couple of shapes, we can make this look much better. This is kind of working reasonably well. If you use the rectangle tool, you can create shapes very, very easily. The problem is that this falls apart once we have other kinds of shapes that aren't rectangles. For those, we have to add all of these tiles as well. So for example, for this corner here, we would need this tile, which means, first of all, you have to activate all of them, like so. Simply left click them, and then you need to draw a shape on them. And at this point, I forgot to mention that the shape is defined by the mode. At the moment, we have corners and sides, which gives us 9 points that we can define. We have the 8 surrounding points and the center. If you only activated corners, then you could only activate one of these corners. And if you only have the sides, then you could only get the top, bottom, left or right, or the center. If you have matched corners and sides, you can combine them. The mode that you want to use depends very heavily on the art assets that you have. For this kind of art asset, you want to use match corners and sides. Most of the time, you do want to use that one, but sometimes you have tile sets that should only connect in one way. But for now, I simply want to draw on the shape for all of these grass tiles and make sure that you don't get any of the gaps. It should look like this, and like this. That looks okay. And now we need the bottom parts, like so and like so. This cross. And then we have all of these tiles, the corner bits that are a bit more complex. Nearly done. I need this part and this part, all of this. And with that, I think we are done. This looks pretty complete. But as always, you do want to test this. So inside of tile map, terrains and grass, you want to simply draw a couple of shapes and make sure they work together pretty well. And I think this works really well. Can't see any kind of problem. So now we can combine different shapes pretty easily. Cool, this works. And I guess for now, I want to get rid of all of this stuff and then create a proper level. So for the player, I want to have a lot more space and then create some kind of outline that works a bit better. Let's say vaguely something like this. And then we can refine things so it doesn't look as blocky. You do want things to look reasonably organic. So let me add a whole bunch of variations like this, like this. And obviously, in your case, you can play around a lot with this kind of system to create a level that you like. I think this looks pretty okay. I guess we could also add a couple of smaller islands that the player cannot reach, but that's not too important. Just a bit of variation, and there we go. That looks like a respectable level. Let's try the entire thing, and if we don't see the coastline, this looks a bit monotone. That we can work on in just a second. But once we do reach the coastline, this looks pretty alright. But the big problem we have right now is that all of this looks pretty bland, which we can randomize a bit more. Inside of this tile set, we haven't used these 4 bottom tiles. They work basically like this center tile, so they should be placed when they're completely surrounded by other tiles, which means you want to select them entirely like this center tile was. Once you have that, back inside of terrains, you can draw more stuff, and now Godot is picking one of these tiles randomly, which is already giving us a lot more variation, which looks better. That being said, I think this is a little bit too much grass. So inside of tile set, we can customize the probabilities, for which you want to go to terrain, and there you have probability. By default, every tile gets a probability of 1. But you can lower this to, let's say, 0.1, and then paint on the tiles that you want to have with this probability. Once you have that, you can paint stuff again, and now, if I draw them on, we get a lot fewer grassy bits. You do want to make sure you cover the entire thing though. Something like this, just play around until you get the right distribution of values. And obviously, if you go to tiles, you can also perfectly fine just create grass tiles yourself where you think they would look good. It's totally fine to combine tiles with terrains. Cool. With that, we have a very basic level. Now, this kind of terrain mechanic is really important, so we should practice it. For the exercise, I want you to create another tile map layer for the soil, the one that will later be used for the plants. The graphic you want to use is called soil.png, and on top of that, create a terrain system and draw a few soil parts. So you can test that it is actually working. Pause the video now and see how far you get. I want to create another tile map layer and rename it right away to soil layer. This, by the way, has to be on top of the grass layer. If it was behind the grass layer, we wouldn't be able to see it because the grass covers it. Anyway, inside of this soil layer, you want to create a new tile set with all of the defaults, and then under terrain set, add an element, match corners and sides, and in terrains, add an element. I called this one soil, although the name doesn't really matter. The color also doesn't matter, although you do want to use a color that contrasts with the tile set that you are working with, just so things are easier to see. I'm going to use pink, but choose whatever you like. After you have that, you want to go to the tile set and then drag in soil.png. We do want to create an atlas texture, and then we are getting all of this. We want to go to paint and then terrains, where we select terrain set 0 and then soil. We basically have to do the same thing that we have done for the grass layer. Select all of them and, using match corners and sides, draw on the shapes that determine how these tiles connect. And this was horrible drawing. If you right click, you can delete these connections, which you are going to do fairly often, at least if you're clumsy like me. So this would be the most basic kind of setup. Let's test this one first of all. Instead of terrains and soil, I can now draw a couple of soil patches, which looks pretty good. Once again, the connection here doesn't work, but that we can fix by defining a few more connections. I want to have all of these parts like so and so. And make sure you also get all of the middle parts. Most terrains work in a pretty similar pattern. If you have seen a couple of them, you should be pretty familiar with the entire system. So this, and then we need all of these corner parts as well. Always takes a few seconds to set this thing up, but it's honestly not that bad. And it's definitely easier than creating all of the levels manually. Last bit here, that looks pretty good. And I guess while we are here, we can also get all of these tiles for variation and define a probability down here, where these should get a probability of 0.1. That should be it. If I now go to tile map, soil, and draw a whole bunch of soil patches, then this is looking quite nice. Cool. I think this works. And later on, we can create these tiles dynamically as well using GDScript. But I think for now, this is a really good start. Cool. Let's keep this part for now for testing purposes. We can use that later on for the plants. First of all, though, we only have the grass bit, but we don't have the water. That we also want to add using another tile map layer. Tile map layer. This one is going to be for the water layer. As always, you want to create a new tile set and then go to tile set inside of the inspector, for which we want to use water.png. And in this case, we do not want to create an atlas texture. Click on no, and then we have to tell Godot which of these tiles we want to use. We only want to use the leftmost one, because these other 3 tiles shouldn't be placed by us, they should be placed by Godot dynamically to create an animation, which you can get by going to select and then select this one tile that we have activated. In there, you have an animation tab where you can define the columns, and in our case, we have 4 columns. After you have that, you can go to frames and add an element. For every element you add, Godot automatically selects the other tile. And those are then going to be played with this duration in mind. Which means we're playing this for 1 second, this for 1 second, this for 1 second, then this for 1 second, and then we're going back to the start. With that, we have animations. So now you can go to tile map. Under tiles, you can only select the leftmost water tile. And if I place it, we are getting an animation. It is very, very slow, but that we can speed up by changing these values to, let's say, 0.4. You want to do that for all of them, and once you have that, the animation is going to look quite a bit better. And if you place more than one, let's say like so and like so, then this is looking pretty alright. Also, this should be behind all of the other layers. Then this effect is much better. While we're here, we can cover the entire bit in water so that we can test the game and see how this is coming together. And now, inside of the actual level, we are getting a pretty good result. We might have to add a bit more here, so the camera doesn't see the background, but other than that, this is working well. There's just one more thing that we do need. We have to add all of the collisions. Just to demonstrate, inside of the game, I can simply walk outside of the grass bit and walk on the water. Not really the intended experience. Fortunately, we can add collision bits to a tile set. All you have to do is go to physics layer and then add an element. where we have the usual collision stuff with a collision layer and a collision mask. The mask we don't need, but we do need a collision layer, and one is for the terrain. So this one can stay as it is. As a reminder, inside of project settings, under 2D physics, we have the 4 layers, and I always use terrain as layer 1, simply because it's the most common kind of collision object that we will encounter. Cool. Once we have that, inside of tile set, under paint, we can paint on a physics layer 0. And I just realized I have worked on the wrong tile map layer. I didn't want to do this for the water layer. This should have happened for the grass layer. So inside of grass layer, for the physics layer, we don't need a collision mask, and we want to be on collision layer 1. Much better. Now, inside of tile set, we can paint on physics layer 0, and there we have the collision bits. If you paint on this part, you have one collision shape. If I go to debug and have visible collision shapes, we can go to the top, and there we are getting collisions. Works pretty well. And to refine this, you can drag these points to a slightly better position, let's say like so. Then it looks much more like we are actually at the coastline, which is better. And later on for the fishing rod, this is going to become really important. I guess I can demonstrate if I find the fishing rod really quick. There we go. You do want to make sure that it looks like we are actually fishing inside of the water. If the collision shape ended here, then this would look a bit strange. Other than that though, this collision shape doesn't matter that much. Also at this point, a pro tip to speed up these kind of collision shape painting processes. If you click on the 3 dots, you can rotate and flip the shape, and using keyboard hotkeys makes the entire thing much faster. For example, if you press R, you can rotate it, and if you press V or H, you can flip it around. That way, I can use the same shape and simply flip it on the vertical axis, and then I have the bottom part. If I press R, I can get this one, and if I now press H, we can get the right side. For the corner parts, you want to add another bit, and if you click on it, you can see a preview of how the entire thing is going to look like. In our case, I want to move this one up here, add one more node, and put this one here. That is almost working well. There we go. This is a nice looking shape. And if I now press R, we can rotate it. And there we go. We have all of the basic shapes. With that, inside of the game, we have made a good bit of progress. And also at this point, we don't actually need these corner bits that much because in practice, all of the other parts constrain the player pretty well. So in this case, the player actually cannot leave the island, which I think is working quite well. Obviously, for a proper game, you do want to add all of the collision shapes, but this is going to take quite a bit of time. And since we don't really need that, I'm going to leave it as it is right now. Cool. With that, we have a basic level created via 3 tile map layers. Next up, we are going to create tiles dynamically, depending on the tool use inside of the game. If the player uses the hoe, we want to create a soil terrain. If the player uses the watering can, then we want to create one of 3 water patches. For all of that, inside of GDScript, number 1, we have to connect the player to the actual level, because inside of the player scene, we are capturing user input, but in the level, we are drawing the soil layer. I think the easiest way of doing that is via a signal. I want to have signal tool underscore use, for which we need 2 arguments. Number 1, the tool that we are going to use. The data type for this is always going to be enum tool. Besides that, we want to have a position, which is going to be a vector 2. And then When we are getting the basic input and we have an action, then we want to emit a signal, which means I want to get tool use dot emit with the current tool and the current position of the player. We are going to refine this quite a bit. At the moment, it is going to work, but it's not going to look pretty. But step by step. Inside of the level, we want to connect this signal, which we can do by going to player, and then inside of node, you should now see a tool use signal. To connect it to the level is going to need a script. So add a script with all of the defaults, and then from the player, connect tool use. Depending on the tool, we need different kinds of logic. So first of all, I want to check what kind of tool we are getting via match. And the first tool I want to check for is enum tool.o. And once again, I hope you see how enums are quite useful. We can simply use match along with the enum, and then from the player, since we can only use enum tools, it's very easy to categorize what kind of tool we are getting. And that would be much better than some kind of string with the kind of tool that we want to use, because this one can be misspelled, or you could be unclear about the spelling. So enums for this kind of purpose are pretty much ideal. Also at this point, you can see that for Godot, enums are just integers, which you can change to enum.tool to be a bit more explicit about it. Things are still going to work just fine. But anyway, for now, I just want to print the current position, just to test things. And also, when we are starting, the current tool by default should be enum tool o. So we always get the right tool for testing purposes. If I now press space, we are getting the position along with tool. This tool comes from the tool use emit function. This one is called via the animation player. Inside of the animation player, for any of the whole animations, let me find them really quick. For example, whole left, we have the frames, and then at some point, we are calling this function. That is going to become important later on to actually emit the signal when we have the right frame inside of the animation. For now, just ignore it. I guess for now, we can replace this with pass, so this function doesn't get in the way. If I now try this again, we are only getting the position, and that is much easier to see. With that, inside of the level, we know when we want to use the whole, and we get a position. That means now we have to do two things. Number one, this position needs to be converted to a coordinate that we can use inside of any of these layers, specifically the soil layer. If you look at the top left, this is the origin point. And when I am placing a tile, this tile would be on position 0 and 0. Or to be a bit more specific, it would have the coordinate 0 and 0. If I go 1 to the right, this would be 1 and 0, 2 and 0, 3 and 0, and so on. If we go down, this would be 0, 1, 0, 2, and you get the idea. We're not working with pixel positions, instead we are working inside of a grid. But from the player, we are getting an actual pixel position, meaning we have to convert this data so that we are getting the right cell depending on the position. And also, this one shouldn't be there, so let me get rid of it really quick. I want to work inside of the script and convert the position to a grid coordinate, which we need a couple of times, so I am going to use it before the match statement. I want to have a var grid coordinate. The data type that we want here is a vector to integer. That way, we are only getting integers inside of the vector, which is a requirement for a grid coordinate. We couldn't, for example, pick a cell at position 1.5. We need integers. And in my case, I want to create a vector to integer, once again, with x and y. And to get these positions, I want to get position.x and then divide it by the tile size, which I have stored inside of data. Somewhere in there, we have the tile size. For every single tile map layer inside of this project, we always have a tile size of 16. So this one can just be a constant. I want to get data tile size, and then do the same thing for the Y position as well. Except now it's going to be position.y. Once you have that, Godot is going to complain quite a bit. We are never in conversion, so a float is converted to an integer and we are losing precision. This happens here and here. So we are getting 2 warnings on a single line. If you really don't like these warnings, you can simply wrap both of them inside of an int statement, like so, and then Godot should be happy. And it is. The only issue now is that we are not using this grid coordinate, which we can change by printing it, and then Godot should be happy. Perfect. Next attempt. If I now press space, we are getting a grid coordinate. And the further up and left I go, the smaller this should become. So now we are on X position 0 and Y position 12. The origin point is somewhere up here, vaguely. The exact position doesn't matter. We only care that this grid coordinate is relative to the player position. Once we have that, we want to create one of these soil map layers dynamically using the terrain, for which I want to get the soil layer and then use set cells terrain connect, for which you need 3 arguments. The cells that you want to place, and this has to be an array with vector 2 integers. So in our case, we are only going to place a single cell, the one that we are getting from the grid coordinate. Grid coordinate, but this needs to be inside of an array. You always have to pass in an array as an argument here. That way you could create multiple cells at once, but in our case, we don't really need that. After that, you need the terrain set and the actual terrain. That in our case is going to be 0 and 0. If you are not sure about these numbers, the first one is the terrain set. That's the one that we have created earlier, and we only have a single one. If we created multiple, let me add an element. This second terrain set would get the integer 1 in here. Same with inside of the terrain set. At the moment, we only have a single one, but if you added another element, you would have to use the index 1 here. It's always a bit confusing for terrains, but you have a terrain set, and inside of the terrain set, you have a terrain. And those are basically stored in an array, so you can pick them via indexing. That is pretty much it. Via a single line, we can now create terrain sets dynamically, or at least I hope we can. If I use the hoe, you can see that we are creating soil patches dynamically. Doesn't work perfectly yet, and the position is definitely off, but we are getting something. We can also connect it to our current soil patch, so this is looking pretty good. But this we want to refine in 2 ways inside of the player. When we are emitting the signal, which at the moment happens inside of getBasicInput, we're getting the current tool and the center position of the player. This is problematic in 2 ways. Number 1, the timing is kind of off. When we are starting the tool, we are emitting the signal right away. But in the game, if you simply look at this in terms of timing, if I use the hoe, we are creating this soil patch right away. But we only want to create it when the hoe hits the ground. It would just look better. Besides that, the position is also off. When I'm using the hoe here, we are creating a soil patch here, but it should rather be here. Number 1, the timing is the easy part. I don't want to emit the signal inside of this if statement. Let me cut it out. Instead, I want to call it inside of tool use emit. That's actually all we have to do for this part. If I now run the game again, the soil patch will only be created when the hoe hits the ground. I talked about this not too long ago, but inside of the animation player, for every single animation, we are calling this tool use emit function on the exact right frame. And this I have manually done for every single animation, not this one, but for example for X up, I moved this tool use emit function around to get it on exactly the right frame. This did take some time, but is a much nicer effect. So that fixes the timing. Next up, we need to have an offset for the position. We are always getting the center position of the player. To that, I want to add some kind of offset depending on the player direction, which means I want to get the current direction and then some kind of distance, which in my case I have set to 16. And then I have also added a vector 2 with 0 and 4. Imagine that this is the player center position that we are getting from the position. After that, we are getting the direction and multiplying it by 16. If the player is looking left, then we are going 16 pixels in this direction. Because of this vector 2, we are going down by 4 pixels. The only reason I added this is because it looked good. That's pretty much it. There's no requirement to add it. Let's try all of this now. If I use the hoe, we are getting a better result with one limitation. If I move in this direction, you can see that we are getting a pretty good offset. But if I stop moving, then this doesn't work anymore. That is because this direction only gets a value when we are moving. Once we stop moving, this value becomes 0 and 0, so this entire expression doesn't do anything. To fix that, all the way at the top, below direction, I want to have var last direction, which is also going to be a vector 2, which we are going to update inside of physics process when we have a direction. So if direction, then I want to update last direction and give it the value of the current direction. That way, once we start moving around, this value gets updated. And once we stop moving around, we retain the value of the last movement direction. And that value we want to use instead of the direction down here. And then we should also be able to get the right direction even when we are not moving. I can go left. If I use the hoe, we get a good offset, maybe a bit too much. And if I stop moving, we are still getting the offset. So this is working. We can also try the other side. I think this is looking pretty good. Perfect. Now we can emit a tool with the hoe. Next up, I want to work on the watering can, which at the moment is purely an animation, which still works pretty well. Also at this point, inside of debug, we don't need the visible collision shapes anymore. Now the system that I want to create is, when we are using the watering can, inside of the level, we are capturing it using this tool parameter. And if that is being used, I want to create the water patches, which should be inside of another tile map layer. And for that, we have soilwater.png. This is just 3 random water patches, and when the player uses the watering can on a soil patch, we want to add one of those images. And this should be random. That part is going to be an exercise. I want you to add the water patches after the player has used the watering can. And this should happen in the same position. For that, use the tile map layer and add one of the random water patches. On top of that, do some research on how to find a soil tile. The player should only be able to add a water patch if there is a soil tile. Quite a bit to work on. Pause the video now and see how far you get. Let's go through it step by step. Number 1. Inside of this signal, we are already capturing the tool, which means we don't need this print statement anymore. Instead, I want enum.tool.water. Just to test this, I want to print the current grid coordinates, and then we can use it. And once again, we are getting the grid position inside of the tile map layer. This we're going to use in just a bit to place a water patch. But first of all, we have to check if in this position we have anything inside of the soil layer. For which, first of all, we have to get the current cell, which we can do via the soil layer and get cell tile data, along with the current grid coordinate. Let me print what we're getting returned. If I use the watering can on a soil patch, we're getting some tile data. And if there's no soil patch, we are getting nothing returned. So ideally, at the very least, for the data type, we want to have tile data. Since we only care about if this cell exists or not, we only care about if this value is null or not, which means we can check if this cell exists, and then we can create a water tile. But for now, let me simply print cell exists and try all of this. If I now use the watering can on a soil patch, we get cell exists. If I do it anywhere else, we don't get that output. Cool, that works. So next up, we can add another tile map layer, which would be for the soil water layer. As always, create a new tile set, and then add the soil water. We do want to create an atlas texture. And now, whenever the player uses the watering can and we have a soil patch, we want to place one of these randomly. You could do that in two different ways. Number one, you could create a new terrain set where these three have the same kind of terrain drawing setup. Like we have done for the grass layer, for example. If I go to tile set, painting, and terrains, you could paint all three of those water patches like these bits here. That would work, but it's also massive overkill. We don't need that much data. Instead, what we can do, inside of the tile set, when you hover over one of these cells, Godot is giving you the atlas coordinate. We have 0, 0, then we have 1, 0, and 2, 0. These values we can pick, and we can just create a random value to get one of those randomly. All we have to do is get the soil water layer and then set a cell. The position for the coordinate is going to be the grid coordinate. For the source ID, we want to have 0. This number you get from tile set. If you look at setup, there you have the ID. That's what this method is looking for. And after that, we need the atlas coordinate. This is what we can set here to pick one of these cells. This needs to be a vector to integer with x and y. Y in our case is always going to be 0. X, however, is going to be a random integer inside of a range. We want to go from 0 to 2. And that is pretty much it. Let's try the entire thing again. Now, inside of the game, if I use a watering can, we can add random water patches. That looks pretty good. You could also, for these water patches, reduce the alpha value a tiny bit. Under modulate, you can lower this value to, let's say, 200-ish. Try this again. Then you get a bit more of a connection between the two, which I think looks better, but play around and see what you like. With that, we have the hoe and the watering can. The next two tools are going to be the fishing rod and seed planting. For both of those, we will need to work more with the tile map layers. Before we do anything, there's one thing I forgot in the last part. If I run the game and I have the hoe selected, which I think is this one, it still works just fine. But if I go here and use it, you can see that this is not exactly the ideal result. This we need to fix. Effectively, I only want to allow these complete tiles to be farmable. All the other ones would look a bit weird, so we do need to be careful. And for that, we have to, inside of the grass layer, define a custom data layer. Add an element there. Then we need a name. I want to call this one farmable. The data type for it is going to be a Boolean. Once you have defined that, inside of the grass layer, under paint, you can get custom data farmable. And then activate the farmable toggle. And now you can paint the values that you want on these specific tiles. If this value is true, we can get this in GDScript in just a second. Then we want to create a soil tile. For all the other ones, it shouldn't be possible. To use that system, when we are using the hoe, before we are doing all of this, I want to check, like we have done down here, the tile data of the layer. Although this should be the grass layer, not the soil layer, on which we can check cell.getCustomData along with the name of the layer, which in this case is farmable, or whatever you have set in this field. If I now try this again, I can use the hoe, and we're getting true for all of these values. But if I go up here, then the game is going to give me false. So this is working. Although you do have to be careful. If we are not on a grass layer, this value is going to be null. And if you try to call getCustomData on a null value, Godot is going to crash. As a consequence, I want to check, first of all, if the cell is different from null, and we are doing all of this. Only then do we want to create a soil patch. With the hoe selected, I can still create soil patches, but if I go up here, it shouldn't be possible anymore, and it isn't. Looks pretty good. That is working. That covers the hoe. Next up, I want to work on the fishing rod, for which we will need enum.tool.fish, and then we have to think about what we want to do. Basically, I guess for now, inside of the player, the default tool should be the fishing rod, so enum tool fish. I can use the fishing rod just fine, but now we have to think about what we are doing. The player shouldn't be able to use the fishing rod on land. That would just look silly. Which means when the player is here, we have to detect if the player has the fishing rod inside of the water or not. Which I think could be a pretty fun exercise. Try to figure out a way to check if the fishing rod is not on the grass layer. Pause the video now and see how far you get. When we have used the watering can, we have checked if our current grid coordinate is inside of these cells. If that was the case, we created a water patch. For the fishing rod, we want to do the opposite, where we first of all get the grass layer, and then we want to check get used cells. This would be all of the cells inside of the grass layer. And we simply want to check if not grid coordinate in this list. If that is the case, I want to print fishing. I guess at this point, there are two ways to check if you have a cell or not. For the water patches, we checked get cell tile data, which would return tile data, and returns null if there's no cell. This would be one way. Besides that, you can also just get the used cells, which I think is a bit more elegant. So just to keep the code a bit more organized, instead of doing these two lines, we can do this single line. The only thing that we have to change is to turn grass layer into soil layer. This part isn't actually needed. Saving one line of code isn't that major, but if you do it often enough, then eventually it will make your code better. Anyway, now we know that we are not inside of the grass layer. Let's test that. And I guess for more testing purposes, let's print not fishing if we are inside of the grassland. Let's try it now. If I use the fishing rod on land, then we get not fishing. But if I get some water down here, then we do get fishing. This looks pretty good. This is all we are going to do for the fishing rod for now. The actual fishing game is going to come later. I just want to have the basic tool in place for now. The actual game associated with it is going to be more complex. So that covers this part. Besides that, I want to create enum.tool.seed, for which we are also just going to do a basic setup. I guess for now, let me simply print the grid coordinate, and then inside of the player, I want to set the default tool to seed. That way, I can run around, and throw some seeds. That works. If the player is seeing a soil patch and there isn't a plant inside of this bit, then we want to create a new plant. Which means, number one, we need to get a few more checks inside of level to check if, first of all, we have a soil patch. This we have done before. Inside of water, we can simply duplicate this line, although I realized this should be without the not part. For water, we do want to check if we have this grid coordinate. And since we are reusing it, we should store it inside of a variable. Let's call it has soil. The value is just going to be all of this without the if statement. That way, we can get rid of this if statement and simply check if has soil here and here. If has soil, then we want to plant some seed. For now, let me add pass in there, because the actual plant is going to be a separate scene. I want to create a new scene, and this is going to be a static body 2D. The plant does not need to move, but I do want to rename it to plant and then save it. Inside of scenes, I want to create a new folder called objects. In there, plant.tscn. To this plant, we now have to add a couple of things. The usual stuff would be a sprite 2D and a collision shape 2D. For the sprite 2D, if you look at plants, there we have corn, pumpkin, tomato, and wheat. Choose one of those for now, it doesn't really matter. Later on, those values will be set dynamically. I'm going to go with wheat, because it looks nice. For the animation, all of those PNG files have 4 H frames. Also, I want this thing to be right in the center. So I'm going to give it a transform of y being -9. Then for the collision shape, I want to have a, let's go with a capsule shape that we have to make quite a bit smaller. Like this and this. Looks about alright. And this one thing we want to create in one of these patches when the player is using the seeds, which we can do inside of level. We just have to preload the plant scene. Plant underscore scene. And we want to preload plant.tscn. Make sure you find the right file. It should be inside of scenes, objects, plant.tscn. Make sure you don't get one of these images. Once we have that, I want to create a new var plant via plant scene.instantiate. That would create the actual scene, but this we have to update in 2 ways. Number one, we have to get the right position, for which we can use the grid coordinate. And then we have to attach it to the scene tree, which in our case means we want to attach it to the objects node 2D. So 2 things that we have to work on. Both of those I want to work on inside of the plant. So plant.setup along with the grid coordinate and the parent, which is objects. This function we now have to create inside of the plant. So with plant selected, create a new script. All the defaults are fine. We just need func setup, for which we have grid coordinates, which is a vector to integer. And we have a parent, which needs to be a node 2D. The 2 really important things that we have to work on is number 1, we have to get the position, which is going to be the grid coordinate. But remember, this grid coordinate is a coordinate inside of a tile map layer. But for this position, we need actual pixel positions. So we have to convert a coordinate to a proper vector 2, which we are doing by simply multiplying it with the tile size. This isn't going to be perfect, but it's going to be good enough, at least for now. After we have that, we have to attach this node to the parent, which we do via parent.addChild with self. You could do this line inside of level as well. I just think this approach is a bit cleaner, but choose whatever you like. After we have that, if I throw some seeds, we are getting a plant that works reasonably well. Although, if I find the watering can really quick, you can see that this position isn't exactly aligned properly. That is because when we are setting up this position, we get the top left of the cell, but we rather want to be in the center of it, which basically means we have to add a bit of an offset and then we are good to go. In my case, I want to add a vector to integer with a value of 8 and 5. That just looked best. Next attempt. Now, if I throw some seed, that looks much more organized, and with the watering can, we can also make sure that they line up with the water patches, and that looks pretty good. One more thing that I do want to add that will become important later on is I want to store this grid coordinate inside of a var coordinate that always has to be a vector2 integer. I simply want to get the coordinate and then grid coordinate. Not necessary for now, but later on to check if this plant was watered or not, this will become important. The one additional thing that I want to do for the plant, we have to set the collision layers. Plant should be on the objects layer number 3, and it doesn't need a mask. Also, for the player, for the collisions, the player can see terrain and the objects, so collisions should still work just fine. Let me add 2 plants, and we get collisions. That works pretty well. We can't go through them, which you might want to adjust by simply inside of the plant, make this collision shape a bit less tall, something like this. Next attempt. That fits a bit better, although now the player gets stuck in the middle, which we can fix by giving the player a slightly shorter collision shape. So make this thing just a bit shorter, and then this should be working. Like so, and like so. And now we can walk between them. It would also work by going up and down. Yep, this looks quite nice. The last thing that we have to cover is inside of the level, via this logic, we can create multiple plants in the same position, which isn't even going to be visible, but let me demonstrate. With a single plant planted, we can look at remote, level, objects, there we have the plant. And if I use the seed again, we are getting multiple static body 2Ds, which are for the plant, which is obviously a problem. So let's fix it. I want to create a var used underscore cells, which is going to be an array. In fact, it's going to be an array that can only hold vector2 integers, on which we want to check when we are using a seed if we have a soil and grid coordinate is not in used cells. However, once we have created a plant, I want to add the grid coordinate to the used cells via the append method. That way, I can throw some seeds. And if I do it multiple times, let's do it 3 times, we can look at the remote tab under objects. I can keep on throwing seeds, nothing is going to happen. But if I go to a different spot, then we are getting more seeds. So that is working pretty well. Perfect. Before we continue, I realized I made a mistake. Inside of the player script, when we are doing the fishing, when the player is able to fish, for now, we just want to print fishing. That part doesn't actually work. And to test it, the default tool should be fish. And now, if I go down to the coast at the south, this is working just fine. We get fishing. However, if I go to the left, then this is not going to work anymore. We do not get fishing. Also, if I go to the top, if I find a good spot, let's say here, this also does not work. Although the right side does work, which is kind of weird. So let me go through what went wrong. And while we are doing that, we can do a bit of debugging. Let's say you encounter this kind of error. Could be quite interesting. And if you want to do a quick challenge, try to figure out what went wrong here. So why can we go fishing on the right side and at the bottom, but not on the left and at the top? There are two issues that went wrong. One has to do with the collision shape, the other has to do with the origin point. Maybe pause the video now and just try to think about it. The first issue is simply inside of the grass layer for the collisions. If I look at paint and the physics layer, the top part is a bit too large. This should be 1 pixel further up. With the top part selected, we can increase the amount of divisions to 8. And then we have much more control over this thing, and we would rather be here. If I now try this again and only go up, and I have to find a flat bit like this, if I now go fishing, we do get fishing. Sometimes you just have to experiment a bit to get the right collision shape. To keep all of this consistent, we can also go here and then account for this shape being just a bit different. We can go a bit further this way. That looks good. And now if I press H, we can go on the right side, and there we go. Now we have a better collision shape. That's the first issue, and this was the easier one. The second issue is the left side. But not just the left side, but specifically the left side beyond the origin point. And to demonstrate this problem, let me, with the tile map and the terrain selected, get rid of a couple of tiles here. So we have a left coast that is in a positive X position. If I simply go there and go fishing, we do get fishing. But if I go a bit further to the left and we cross the 0 point on the x-axis, we do not get fishing anymore. Imagine we have a coordinate system like so, where this point is 0 on the x-axis. Then we have the positive values on the right. This would be in pixel positions, 16. Then we have a bit further to the right, 32. And if we go to the left, we would get negative 16, and we would get negative 32. Now imagine if the player is in this position and we are looking to the right. And the point that we are sampling is 20 pixels to the right, which means we are vaguely here. And if we divide this point by 16, we're going to get 1 point something. And since we are only getting the integer, we are here, exactly on 16. And then we are drawing a tile vaguely here. This works perfectly well. On the right side, we do not have an issue. However, imagine now we are going the other way, where we are going negative 20 pixels, which means we are ending roughly here. Once again, we are dividing all of this by 16, so we're ending up here. The integer outcome is going to be negative 1 on the grid coordinate system. The math so far is still working just fine, but the actual issue is that we are always placing the top left. So now we are placing the tile here, which is really, really close to the player. The actual correct position would have been here. So if we get negative values, we have to offset these cells by 1 value to the left or further up. And actually, I can demonstrate this. Let's do a bit more debugging. I think that's generally good practice. I want to have a tile map layer that is just going to be a debug layer. On there, we need to have some kind of tile that's very easily visible, which in my case is going to be a tile set with the defaults. And then inside of that tile set, I want to add tile sets with roof.png, which you have to drag into the tile set. And we do want to create an atlas texture. I want to use this middle tile for debugging purposes and update it on every single frame, so we know exactly where this grid coordinate is, for which we can use physics process. And fundamentally, I want to get this value. We also don't need delta time, but we do have a problem. This position we are getting from the parameter inside of onPlayerToolUse, which we don't have available inside of physics process. To get around that, I want to store the player inside of a variable. Var player is going to be the player, like so. After we have that, we can simply assign the position to player.position. Also, don't forget, when we are getting a node, this needs to be on ready. So Godot is happy. Besides that, what is really important is that for this position, we don't want the center of the player, we want to get the offset position. All of this stuff here needs to be in there as well. Let me copy it and paste it in there. The one thing that we have to change is this should be player.lastDirection. Now we get a position and the grid coordinates. That means we can get the debug layer and set a cell. The target position for the coordinates is going to be the grid coordinates. I want to get the source ID 0, and the actual tile that I want to place, we can get from tile set, if you hover over it, is going to be 1 and 3 inside of a vector to integer, 1 and 3. And this is going to draw a new tile every single time we are creating a physics frame. Before we are doing that, I want to get the debug layer and clear it, meaning we are clearing the entire tile set. Then we are drawing one cell, the one that the player is looking at. And now, if I run the whole thing, you can see where the player is actually looking at. And if we go up, this works. We have the right tile. If I go to the left, we also have the right tile. And if I go all the way down, this will take a second. Once again, we do get the right position. However, if I go further to the left, at some point, the x values are going to become negative. And then you can see this tile is exactly on the player. It's not to the left anymore. Because of that, we can't go beyond the left coast. But if we go to the right or down, this issue never comes up. The really important question now is how do we fix it? And well, all we have to do is add an offset if position x or y is negative. Grid coordinate.x plus equal -1 if position.x is smaller than 0. If that is not the case, else we want to add nothing to it. The same thing we want to do for y, and make sure you also get position.y. If you add these two offsets to the grid coordinate inside of our debug physics process, then all of this is still going to work just fine. If I now go to the left, the target position is always a bit further than the center of the player, which is exactly what we wanted. The other sides also work just fine. Let me just test them. This looks good, and this looks good. Cool, with that, we have fixed a pretty annoying bug. We don't need all of this anymore. And we also don't need this debug layer. Although in practice, if you're making a real game, you do want to have a couple of debug tools. Getting the player target position is really important for this kind of game, so you would want to keep it. The last two tools that we have to work on are going to be the axe and the sword. Those actually work in a really similar way. The only real difference between them is that they have different targets. The axe is only for trees, and the sword is only for enemies. Which means for this part, we also have to add those. Let's jump right in. Here we are back in Godot, and inside of the level, we have hoe, water, fish, and seed, and I want to add two more cases. enum.tool.x. That being said, since the logic for the axe and the sword is basically the same, we can cover them at the same time. So I want to have enum.tool.sort as well. If either of those is the case, I want to print X or sort. And just for now, inside of the player, I want to have the default tool as let's go with the X. Let's try all of that. And now I have the X tool. Once we have that, inside of the level, instead of printing things, fundamentally all that we need to do is to get all of the objects that could be hit. I'm doing that via a for loop for object in get tree, get nodes in group, and the group is going to be called objects. Inside of this for loop, we are going to check if the distance between this object and this position is smaller than a certain amount via if object.position.distance_2. And then we are getting the position from the parameter. If that value is, let's say, below 20, then we want to call object.hit along with the tool that we are using. That way, for example, inside of a tree, we can check if we got hit by a sword or by an axe. Which means now we have to create a tree, which is going to be a static body 2D node for the root node, which I want to rename to tree. Save the entire thing inside of scenes and objects, and then we can do the usual stuff. I want to add a sprite 2D along with a collision shape 2D. For the sprite 2D, you want to go to graphics. There we have objects, actually plants. I think in there we have the tree, this one here, and then add it to the texture. You can see we have two trees. Later on, we're going to pick one of those randomly. But for now, instead of animation, I want to set 2 H-frames and then pick the one that you like more. For the collision shape, I want to create a capsule shape 2D with a radius of 8 and a height of 22, which I also want to move down a tiny bit. So under transform, Y should be 4. Finally, don't forget, inside of collisions, you want to get the right layer. We want to be on the object layer, and we don't need a mask. Once we have that, inside of the level, to the objects, I want to add the tree scene and then move it vaguely here, so we can see how this is going to look like. Now, inside of the game, this is working pretty well. Looks like a tree. Also, what I forgot to mention earlier on is inside of objects, under ordering, I have Y-sort enabled. If we don't have that, let me disable it, then we wouldn't get Y-sorted. So the player is always going to be behind the tree, because inside of the scene tree, the player comes before the tree. As a consequence, you do want to have Y-sort enabled. Now that we have that, we can work with the tree. That means we have to make this for loop usable, for which, inside of the tree, I want to go to node, groups, and then add a group called objects. On top of that, the tree is going to need a script where we have the hit function along with one parameter for the tool. Func hit along with the tool that we are getting, which is going to be an enum tool in terms of the data type. And for now, let's simply print the tool that we are getting so I can test things. If I now use the X, we're getting 0. And if I find the sword, that one is the index number 2. And that works. Perfect. Now that we have the basic setup, there are a couple of things that I want to do. Number 1, the tree should flash when hit. For that, we're going to use a shader. On top of that, there should be apples that disappear when the tree gets hit by an axe. And finally, the tree is killable. Let's say after we have hit the tree 3 times, it should become a stump. That is going to be quite a bit. Let's go through it step by step. Starting with the first part, we want to make the tree flash. Now this effect we want to reuse a couple of times, which means I don't want to have a sprite 2D for that. Instead, I want to create a separate scene that we are later on going to reuse. In other words, I want to create a new scene where the root node is a sprite 2D, which I'm going to rename to flash sprite 2D. Save this one inside of a new folder. Let's call this one VFX and save it in there. And just for testing purposes, to this flash sprite 2D, I want to add an image like this apple, for example. What you put in here at the moment does not matter. What does matter, however, is inside of the material, I want to add a new shader material. To that material, I want to add a shader, and I want to use a visual shader that we can rename to I guess flash.trace would work, although later on it's going to do a bit more, but good enough. Also, I want to save it inside of the shaders folder. It's a bit cleaner. So shaders.flash for the file path, create, and now we have a visual shader. We don't care about the vertex shader, we want to work inside of the fragment shader. In there, we want to target the color. All we need for the flash effect is to mix this color with some generic color, in my case white. So we need to have the original texture color, which we're getting from the input color node. If I connect this to the output for color, nothing changes. We get the original colors and we set the original colors to the new colors, so nothing changes. Besides that, I want to have a color parameter, which should only be called color, and in there, I want to have a default value, which is going to be white. And those two values I want to mix, which we can do via a mix node. Just make sure that you are getting a vector 3 or a vector 4. Both are fine. I'm going to go with a vector 3 and then mix the input color along with the color parameter. That will tint the color whitish, because right now these values are 0.5. So we get the exact midpoint between these two values. To customize that bit, let me clean this up just a bit. That feels better. To customize this value, I want to add a float parameter that I usually call progress. And this we want to connect here. Also, we can set a range to go from 0 to 1. Once you have that, inside of shader parameters, we have a progress value where we can go from 0 to 1 and flash this sprite. Works pretty well. Also really important, what you basically always want to do for shaders, under resource, you want to enable local to scene. That way, if you have multiple scenes with the shader, they work individually. If you hadn't this enabled and you hit one tree, all of the trees are going to flash. With that, we have a basic shader that lets us flash this sprite 2D. On top of that, I want to add a script to it with all of the defaults, and then add a basic func flash that toggles this animation and that we can customize a bit. I want to have a start duration, which is going to be a float with a default of 0.2. Then I want to have an end duration, also a float with the same value, 0.2. And then we can create a tween for the animation. So create tween. All I really want to do is to tween a property. The object that we want to target is the material of the sprite, which we can get via the material. The property path that we want to get is called shader underscore parameter slash progress, or the value that you have set in here. Then we need a final value, which in my case is going to be 1.0. And finally, a duration that is going to be the start duration. That way, we are setting this value to a 1, which is going to turn the sprite purely white, like so. After we have that, I want to go back to a value of 0.0 for the duration of the end duration. With that, we have a tween that controls the shader, and this we want to use. Inside of the tree, I want to get rid of the sprite 2D and replace it with the flash sprite 2D, which at the moment has the apple. Let's get rid of that one. And instead, I want to add the tree to it, like so. And under animation, once again, we have 2 H frames. And while we are here, progress inside of the flash sprite should be 0. And inside of the tree, under material, shader material, and the progress, this should be 0. That way, inside of the game, we are getting the exact same result. However, what we can now do, when we are calling the hit function, I can simply get the flash sprite and call the flash function. Since we have default parameters, we don't have to call it with any arguments. So now let's try it. If I use the X, we are getting a flash effect. That looks pretty good. Although this we only want to do if tool is equal to enum.tool.x. And that covers the first part. Next up, we want to add apples, for which to the tree I want to add a node 2D that I have called apple spawn positions. In there, we are simply going to have a whole bunch of marker 2Ds. And this is always going to be a position where we could spawn an apple. And I want to have multiple all across the tree, so we get lots of potential random positions. One here, and one here. I guess that looks reasonable enough. We can fine-tune all of this when we have actual apples. Now the logic is going to be, we are adding this apple as a texture to the scene. And when the tree is ready, we are creating sprites in one of these random positions. For which I want to have a function create apples with one parameter, the number of apples that we want to create, which has to be an integer. After we have that, I want to get a handful of these markers and they have to be unique. I don't want an apple to be in the same position twice. I want to get the apple underscore markers, which we can get via the apple spawn positions dot get underscore children. And this list we want to duplicate, which should be a deep copy. That way, this list is unique. So we can change it and delete values, which is going to become important in just a second. And the deep copy just means that you are creating a list that is independent of the list that we have gotten from here. After we have that, I want for I in number, for the number we have specified up here, and then create a var position underscore marker, which is going to be one of the apple markers, and I want to pop at a random position. That way, we are picking one of these values and remove it from the list, for which we are going to need a random integer within a range. We always want to start from 0, and our final value is going to be apple markers.size -1. Once we have that, we can create a var sprite, which will be a sprite2d.new. For this sprite, we will now need a texture. All the way at the top, I want to have a const apple texture, which we can preload by getting graphics, plants, and apple.png. Do be careful here. You want to have the apple inside of the plants folder, not the icons one. That one looks different. Okay, once we have that, we can get sprite.texture and assign the apple texture. Now we have a sprite, and we have to do two more things. Number one, we have to place the sprite in the right position. And for that, we have to position marker. Besides that, we have to attach it as a child to the scene, for which I want to have another node 2D called apples. And then I want to get these apples and add child with the sprite. On top of that, sprite.position is going to be the position marker.position. And that should be it. If I now, inside of func underscore ready, call create apples with, let's say, 3 apples, then we are getting 3 apples. The other stuff also works just fine. Cool. That almost covers the next part. The one additional thing that we need. When the tree gets hit, we want to remove one of the apples, which I am doing via a getApple function, which we have to create. So func get apple. Fundamentally, we want to check if apples and get children does exist. So we have a value inside of this array. Then I want to get the list again. Let me copy it. I want to pick a random child and q3 it. That way, it's going to be deleted. On top of that, I want to print get apple. The actual logic for the resources we will work on later. For now though, if I hit the tree with an X, an apple disappears, and this works multiple times, so this is looking pretty good. Cool, with that, we have the apples. Finally, the tree needs to be killable, which means the tree should have a health variable. With some kind of default value, choose what you think is best. I'm gonna go with 3. And then, every time the tree gets hit, I want to reduce this number by 1. So health minus equal 1. To track this value, inside of the health variable, I want to add set value, in which we can do stuff when we are updating the health variable. In case you don't know this one, when you add set value, this function is going to be run every time this value updates. You get one argument, which is the value that would be the new value that we are getting here. And the first thing that you always have to do is to actually update the variable itself. If you don't add this one, then this variable can never be updated. Let me just demonstrate. I want to print the value that we are getting after we have run health minus equal 1. Inside of the game, if I use the X, we get 2, 1, and 0. And this could even become negative, although in practice, this one wouldn't happen. This functionality is super useful to track if a variable changes. Especially for things like health, it's super useful. Because now, we can do things like if health is smaller or equal to 0, then we want to print tree dead. And now, 1, 2, and 3, and we get tree dead. Perfect. If that is the case, I want to hide this tree and show a tree stump instead. You can find this one inside of the plants folder. Make sure you are aligning this one just right under transform. In my case, the Y position is 10.5. Definitely double check, but I think this looks pretty good. And by default, this one should be behind the flash sprite, like so. By default, it should be hidden. However, if health goes below 0, then I want to hide the flash sprite. So flash sprite.hide, and the stump should be shown. So stump.show. With that, I can hit the tree a couple of times. And there we go. The tree disappears and we are left with a stump. This is almost perfect. The one issue is, if I show the collision shapes, and I get rid of the tree again, like so, you can see that now the collision shape just doesn't make sense anymore. This we have to update. For which, I want to create a new shape. The object that we want is a rectangle shape 2D. .new. And on the shape, we can set a size. In my case, for this one, I want to use a vector 2 that is 12 pixels wide and 6 pixels tall. Once we have that, we can get the collision shape 2D and update the shape to the shape that we have just created, this stuff here. On top of that, this collision shape should be moved down a bit to align perfectly with the sprite 2D. Position.y, in my case, is going to be 8. And that should be it. If I now hit the tree, there we go. This is a good collision shape. And nothing else is going to happen. With that, we have the basics of the tree. That covers the first part. Next up, I want to create an enemy, which will be the blob. Inside of characters, we have blob.png. Like for the player, we have a ton of animation frames, although most of those don't really matter. We only care about the first row. There we have 2 idle frames, those you can entirely ignore. Then you have a whole bunch of movement frames, and at the end, you have an explosion animation. All of this should be used for the enemy blob, and this part is going to be an exercise. Let's go through it one by one. I want you to create a blob enemy. It should play the move animation and also move towards the player. Besides that, it should flash when hit by a sword and be pushed away from the player. Finally, play the explosion animation when this monster is defeated. This is going to be quite a bit, but I think you can do it. So pause the video now and see how far you get. I don't want to have a sprite 2D. Instead, since we want to move this object with collisions, I need a character body 2D, which I want to rename to blob. Save this one inside of the objects folder. And as always, we are going to need a sprite 2D. Or actually, this shouldn't be a sprite 2D. This should be the flash sprite 2D. Besides that, for the blob, I want to add a collision shape 2D that we are going to set in just a second. First of all, though, for this flash sprite 2D, I want to add blob.png, like so. And then we have to set the H and V frames. We have 14 H frames and 4 V frames. Once we have that, we can animate the thing using the frame property. First of all, though, I want to add a collision shape, which I think can just be a circle that we are scaling down, vaguely this. After that, I want to add an animation layer, because later on, these animations are going to become a bit more complex. There are two animations that we need. The first one is the move animation. The second one is explode. For move, I simply want to have a property track, flash sprite 2D, and the frame property. This animation should be 0.8 seconds long. And we want to get the keys for value number 3. Then after 0.2 seconds, value number 4. Then we get value 5. And finally, you can see where this is going, number 6. If I now play the animation in loop, we get a moving animation. Perfect. This one should be auto-playing. Besides that, for the explosion, the duration should be 1.4 seconds, and I want to add a property track for the flash sprite, and then for the frame property. The first frame is going to be frame 7, and then we need the next 7 frames. Frame 8, 10, and let me just add all of them and skip ahead a tiny bit. There we go. We have the frames from 7 to 13. If I play the thing, we get an explosion, which looks pretty alright. Although by default, we want to play the move animation. And besides that, for the blob, we have to assign it to a group called objects, like we have done for the tree. We have to add a script, create, and then func hit along with the tool, enum.tool. For now, let's simply print it. Actually, I guess what we can also do is flash sprite 2d.flash. And then inside of the level, we can add the blob to the game. We just have to move it down a bit. Let's move him here. And now we have to select the sword. That looks good. And if I hit the blob, we get a flash animation. It works just fine. Good start. Although what I forgot to do inside of the blob under collisions, this guy should be on layer 3. And for the mask, we want to see the terrain. Once we have that, we can move the blob in the direction of the player, for which I want to have a couple of variables. The first one is the direction, which is going to be a vector 2. We'll set an actual value in just a second, but first of all, we need a speed. Let's set this one to 20. And then, most importantly, on ready var, we need the player. How can we get that one? And well, I think the easiest way of doing that is get tree, get first node in group, player. For that to work, inside of the player, we have to assign the player to a group called player. And that we can use inside of func_physics process. The direction we can get via fairly simple vector math. We want to get the target position minus the current position, which in our case is going to be the player.position minus the position of the blob. And this we need to normalize. After that, we can update the velocity to direction times speed. And finally, don't forget to call move and slide. And also, we don't need delta time. That should do something. Now the blob is going to move towards the player, and that works quite well. Perfect. Later on, the target is going to be different. The blobs are only really going to attack the plants, but that's going to come later. I just want to have something for the movement for now. Next up, I want to add a func that I called push. Whenever the player hits the blob, we want to push the blob away from the player, for which I can add a tween via get free and create tween. And for all of that, we will also need a target direction. This is going to be similar compared to what we have done up here. Let me actually copy it. We get the distance from the player to the blob, and we want to go in the opposite direction. So this we want to multiply with -1. Also, we want to go further than a vector with the size of 1. So this I want to multiply with a push_distance, which doesn't exist yet. So var push_distance with a value I have gone with 130. Now we have a tween and a target. That means now we can mess with the velocity. The way I have done that is I created a var push_direction, which is also going to be a vector 2. And this push direction we're going to add to the velocity. Push direction. And that way, whatever this value is going to be, it's going to influence the movement of the blob, which we are going to set via the push function and a tween. Effectively, all I want to do is tween property where I'm targeting the blob itself, and then the push direction variable. The target value is going to be target, the thing we have just done, and for the duration 0.1 seconds. After that, when the tween is done, the target should be vector 2.0 over a duration of 0.2 seconds. So we are pushing the blob for this amount of time, and then we stop doing that. And all of this changes gradually, which means now inside of the hit function, I can check if tool is equal to enum.tool.sort. And if that is the case, we want to flash the thing and we want to push the thing. Let's try. Make sure you have the sort selected. And now, if I hit the blob, it's being pushed away from the player. You might want to move him a bit further away, but that is a minor detail. Finally, we will need a var health. Like for the tree, this thing is going to get 3 health points. And we want to monitor this value via set value. In which, don't forget, you want to update the health value. And fundamentally, all that we want to do in here is if health is below or equal to 0, then we want to play a death animation, which doesn't exist yet. So let's do it below push, func, death. For now, let's add pass in here. And also, when the blob gets hit, we want to reduce the health by 1. Inside of death, I want to set the speed to 0, so the blob stops moving, and then get the animation player and update the current animation to explode. Or whatever you have set inside of the animation player, you want to get this value. After this thing is done, we can get rid of the entire blob scene, for which we can work inside of the animation player and inside of explode add a call method track. We are targeting the parent, and then all the way at the end, insert a key and get Q3. Put it here, and then we should get the explosion and have the blob disappear once the thing is over. Let's try. I have to make sure I get the sort. 1, 2, and 3. And now the blob explodes, but doesn't disappear. That is probably because with the Q3 selected, time is at 1.433. But the duration of the animation is 1.4. So I just have to put it in the right position, 1.4 at the end of this timeline. Next attempt, let's attack the blob. Now it explodes and actually disappears. Much better. Alrighty, that was a long one, but at least now we have all of the tools. At this point, we do have all of the tools, at least in terms of their basic functionality. That being said, we can't see what kind of tool we are getting inside of the game. To fix that, we're going to add a UI element that indicates what tool is being selected. Makes the game feel much more controllable. And for all of that, back inside of Godot, first of all, I want to close a couple of things. We don't need the plant, the tree, the flash sprite, or the blob enemy. In fact, inside of the game, the blob should be removed so we can focus on the tools. For which, I want to create a new scene where the root node is a user interface, which I want to rename to Tool UI. Make sure you're saving the entire thing inside of scenes, and I want to have a folder for UI, Tool UI, save, and then this scene should be attached to the player. We can do it like this, where we are attaching the Tool UI scene to the player character node. This at the moment is not going to change anything, because inside of Tool UI, we have nothing visible. But that we can change. Just to test things, I want to add a color rectangle with a white color that spans the entire available space, like so. If I now run the game, we still cannot see anything. And now you might be confused. Inside of Tool UI, we are covering the entire available space. But in the player script, we can't see anything. That is because when you add a control node, so one of the green ones, to a 2D node, one of the blue ones, then the green node will be scaled down to the smallest possible size, which at the moment is always going to be 0 and 0. That, however, we can change inside of layout, custom minimum size. If I set this to 100 in each dimension, run the game again, then you can see that we have a UI element on top of the player. Not ideal, but definitely a start. Now, just to get the basics right, this color rectangle later on is going to be a container for the tools. The custom minimum size should be 100 pixels by 30 pixels. Once you have that, make sure that you are clicking on this center button, so we are occupying the smallest possible space inside of the center, which in the game is going to look like this. It feels alright in terms of size, but we do have to move it up a bit. And for that, the Tool UI at the moment covers the entire screen space. This I don't want to do anymore, so this should be centered. And after that, this color rectangle should be a bit to the top. Imagine here's the player, and the Tool UI should be above that point. For that, with the color rect selected, go to Anchors preset and then Custom. Once you have that, you can set the anchor points, and I want to set all of those to 0. Brings us back to the original position. At the bottom, we can add an offset by setting this to -10. That way, we are moving up just a bit. Let's see how that looks. Definitely not enough. Let's for now go with -30. And then we should at least somewhat see the player, and that feels a good bit better. This color rectangle should be holding all of the tools, which means it should be a tool container. And the node type that we want to work with, so right click and change type, should be an HBox container. That way we can organize things on the horizontal axis. Although with that in practice, you cannot see anything anymore. For that, we will need another node, which is also going to be a user interface, which I called Tool UI Texture. Save this one inside of the same folder, like so. The only thing that we want to do in here is, for now, add a texture rectangle. This is what the player will actually see. So for example, if you go to graphics, there we have somewhere inside of the icons, all of the tools, and also later on, all of the items, like an apple, corn, things like that. Although for now, I only want to use x.png. On top of that, inside of Tool UI Texture, the layout, I do want to set a custom minimum size of 20 by 20 pixels. And this node should not scale. Inside of Anchor Preset, set it to top left, and then we are covering 20 by 20 pixels. Inside of that space, I want to have the X. And to scale it properly, I want to set the expand mode to fit width. On top of that, make sure that with this button selected, you want to cover the entire full rectangle. That way, we are inside of the Tool UI texture space. Save the entire thing and back inside of Tool UI to this tool container, add Tool UI texture, this one here. If you now duplicate this 6 times, then you get a vague preview of how the entire thing is actually going to look like. Looks okay, we do have to refine it a bit, but definitely a start. But let's go through it step by step. Number 1, all of these Tool UI textures should disappear because we want to generate them dynamically. For that, to Tool UI, add a script with all of the defaults. When this scene is ready, so func_ready, I want to create all of these Tool UI textures. For that, I need a bit of information. Most importantly, I will need the kind of texture that we want to use. So for example, for the X, we want to have x.png. For the fishing enum, we want to have fish.png, and so on. If you look at pre-made and code snippets, there you can see we have a const tool textures. Copy the entire thing, like so, and then paste it into tool ui.gd. Via this constant dictionary, we can connect the enum of the tool with a texture from the icons folder. So x is connected to x.png, ho to ho.png, and so on. And to keep everything organized, I want to call a texture setup function, which is going to accept up to 4 arguments. The first one is going to be for all of the enums, which in my case is going to be enum.tool.values. That way, if you look at enums for the tools, we will be getting all of these values. In fact, let me create the function. So func texture underscore setup, in which for now, I want to have an enum underscore list, which I want to print enum list. And now, if I run the entire project, we're getting a list with the enums, where we are going from 0 to 5, with 0 being the X and 5 being the seeds, I believe. Whatever we are getting in here, the order doesn't matter. The data type here should always be an array, just to keep things consistent. After that, I want to have the textures. This is going to be the enum dictionary that we have created up here. So the data type for this one is always going to be a dictionary. After that, I want to have a container or parent, whatever you want to call it. This is going to be an HBox container. In fact, the HBox container that we have created here. Tool container at the moment. That's going to be it for now, although later on, we will add one more parameter. At the moment though, when we are calling texture setup, I want to get the tool textures, and then the container is going to be the tool container. Once we have that, we have all of the basic info that we need to instantiate Tool UI texture with the right information. That being said, we do need the scene itself, which means inside of Tool UI, besides the tool textures, I want to have a var tool button scene where we are preloading the Tool UI texture.tscn. I want to create a for loop to cycle through all of the enums. before, let's call this one the enum ID in enum list. After that, we can create the tool texture, and I realized this shouldn't be tool button scene, this should be the tool texture scene, because it's not a button, it's just a texture. You can't press it. We want to have the tool texture scene and instantiate it. After it has been instantiated, container dot add child along with the tool texture. This would already do something. If I now run the script, you can see that we are getting the 6 tools again. We are always getting the X because that is the default texture that we are getting in there. Not perfect yet, but definitely a start. To go a bit further and customize this texture, I want to add a script to it. The defaults, as always, are perfectly fine. What I want to do in here is to create a func setup where we are getting a new tool enum, which is going to be enum.tool. Then I want to have a main texture, which is going to be a texture 2D. And all of this I do want to use right away. The new tool is going to be the tool that we need to identify what we are working with, which is a fancy way of saying I want to store it inside of a variable tool enum, and this is going to be enum.tool. The value for this one is going to be what we're getting from the parameters, like so. Besides that, since we are getting the texture from the parameter as well, we can grab the texture rectangle right away, like so, and overwrite the texture with the main texture value. With that in place, we have to call the setup function inside of tool UI after we have instantiated the scene. Tool texture.setup, where we need the tool enum and a texture. The tool enum is simply going to be the enum underscore ID from the for loop, the one up here. The texture we can get from textures, and in there we can get the enum ID. That should be it. Inside of the game, we are now getting all of the tools. Definitely progress. The one thing that we definitely have to work on is going to be sizing, for which inside of the texture rectangle, I want to set a custom minimum size. So with texture rectangle selected, go to layout and set a custom minimum size of 16 by 16. This doesn't change anything at the moment because we are scaling this texture up to cover this entire space, which is just a tiny bit larger, 20 by 20 pixels. To fix that, you want to center it inside of the space, and that makes it a bit smaller. We do want to have just a bit of space around it, so we can scale it up later on without making it look too weird. But now, inside of the game, this is drastically better. I think we need to move it up just a bit, but that's a small thing. Inside of Tool UI container, layout, and anchor offsets, set the bottom side to -10. I think those numbers have changed, but just play around with them and see what looks good. I think that works pretty well. Sometimes Godot can be really weird about these values. Anyway, with that, we have a good container, and that looks pretty alright. That being said, inside of the game, we only want to show this when we are changing the tool. And while we are doing that, we also want to highlight the currently selected tool. Because at the moment, if I change the tool, we can see all of the tools, but we can't see which one is selected. So not great yet. When this scene is ready, I want to hide the tool container. Tool container.hide. And then we only want to show it when the player is changing a tool, for which we have to work inside of player.gd. When we are getting the basic input and changing the tool, we are doing this one here. Then I want to get the tool UI, the one that we have attached to the player, this one here. Let me drag it in, tool UI, and then we want to reveal it. This function does not exist at the moment, so func reveal inside of toolui.gd, And then we basically want to do the opposite that we have done before. Toolcontainer.show. If I now run the game, change the tool, we can see the tools permanently. But this should disappear after a short amount of time. To the tool UI, I want to add a timer node, which is going to be the height timer. That's going to get a duration of 1 second, and it should be one shot. We also want to connect the signal to the scene, so connect timeout on hideout timer. Once this timer finishes, I want to do what we have done up here, toolcontainer.hide. Once we're revealing the container, I want to get the hide timer and start it. With that, when we are changing the tool, it should disappear after a second. And if I keep on pressing the tool change, the UI keeps on being visible because we keep on restarting the timer. That looks good. With that covered, we have to work on the actually important part. If any of these tools is selected, the tool should scale up a tiny bit. So for example, if the X is selected, the X should be a bit larger than the other tools. For that, inside of Tool UI, when we are revealing all of the tools, we need to know what the current tool of the player is. That we can do in a couple of ways, but fundamentally, I want to get, let's call it a target. And this target basically is going to be the current tool or the current seed of the player. For now, we are only going to work with the tool. There are a couple of ways of getting this value, but in our case, what I think is quite simple. Since the tool UI is a direct child of the player, what we can do inside of tool UI is get the parent, and that way we're getting the player right away. Now you do have to be careful here. If the tool UI node was not a direct child of the player, this would not work. If we ran getParent instead of the animation tree, we would get this animation node. But in our case, this one works perfectly fine, so getParent is good enough. Since this is the player, we can get the current tool right away. Now we have the target that we want to scale up. And effectively, we want to look at all of these tool texture scenes and check if the attached enum is equal to the current tool, which we're going to do via for texture in the tool container.getChildren. That way, we are targeting all of the tool textures. And on there, I want to call a highlight function, for which we only want to check if the target is equal to texture dot this tool enum that we have assigned to it earlier. Let me copy it and paste it in there, and do make sure that this is a comparison operator. Once we have that, inside of tool UI texture, func highlight with one parameter, let's call this one selected. It's going to be a Boolean, and all we have to do to scale it up is to create a tween. Create tween. Besides that, we will need a target underscore size, which is a vector2 with a size of 20 by 20. This is the maximum size, and this we only want to get if this tool texture is selected. If that is not the case, else I want to return to a vector2 that is 16 by 16 pixels. And finally, I want to call tween along with tween property, where we are getting the texture rectangle. We want to target the custom minimum size and then use the target that we have created up here. Finally, we will need a duration, which I have set to 0.1 seconds. If I now select different tools, you can see they're scaling up a tiny bit, which I think is a nice indicator that works really, really well. Righty, with that, let's do an exercise. I want you to create the seed UI as well, for which I just want you to expand the tool UI and tool UI texture scenes. Do not create a new one entirely. Both of these can be expanded to incorporate the seed functionality as well. The end result, by the way, should look like this. Also, if you look at the player script, there we are selecting a current seed, and that is the information that you want to use. Finally, inside of the pre-made folder in the script, you can find the dictionary that links the seed enums to the seed textures. Just to demonstrate, if you look at pre-made and code snippets, this is the dictionary that you can use to link the seeds to the seed textures. Saves you a bit of typing. So, pause the video now and see how far you get. Back inside of Godot, I'm going to copy this dictionary and go to Tool UI. We can paste it right below the tool textures. That way we are getting the textures that we need super easily. Besides that, we need to think about what we want to do. And most importantly, besides the tool container, I want to have another HBox container, which is going to be the seed container. Since the tools and the seeds are quite different, I think it makes sense to have different containers for them. Although I don't want to create it like this. Instead, I want to duplicate this one. That way we keep all of the values, which is a bit easier. This should be the seed container. And to create all of the textures, we can reuse the function that we have created here. We simply have to duplicate it and then change a couple of values. First of all, I want to have enum, seed, and values. Inside of the enums, we have these 4 seeds, and we want to select one of them. For the textures, I want to have the seed textures, and the container should be the seed container. That should do something. Let's try. Here you can see, we are getting the basic seeds. Looks pretty good. Although they shouldn't be visible by default. At the moment, we are only hiding the tool container, not the seed container. To fix that, you could simply add seed container like so, and then they would be hidden by default. That works pretty well, although what I think is a bit more elegant is for container in the array with the tool container and the seed container, in which you simply want to run container.hide, and then this looks a bit more organized. If I run the scene, the tools still work just fine. They also disappear, but if I now press the seed change button, then nothing is going to happen, because inside of reveal, we only reveal the tool container. To fix that, I want to dynamically target the right container, which I am going to call the current container. This can be the tool container by default, but only if we are getting a tool, which should be a parameter inside of reveal, tool, and boolean. If we are not getting a tool, else, then I want to get the seed container, like so. And finally, I want to get the current container and show it. That covers this part of the logic, but we also, inside of the player, have to call tool reveal when we are changing the seed. So copy paste it in there. When we are getting the tool, this value should be true. And when we're getting a seed, that value should be false. And now I can select the various tools. That looks pretty good. And if I use the seeds, this also kind of works. We do see the container, but none of these scale up whatsoever. And I think you can tell why. When we are doing this for loop, we are checking the current tool of the player, which doesn't match up with the target enum. Like we have done up here, I only want to get the current tool if we are getting a tool, and if we don't, then else get parent and get the current seed. That way, we're getting the right target. Besides that, this texture at the moment loops through all of the children of the tool container, which we want to replace with the current container. And now, if I use the seeds, we are getting a nice animation. This works super well. Also, the tools still work, but there we have a bit of an issue. When using the tools, the seeds should disappear. And vice versa, the two of them should never be visible at the same time. That's an easy thing to add. When we are calling reveal, I first of all want to hide both containers, like we have done up here. I can actually duplicate both lines like so. And after we have done that, I want to show the current container. That should look much better. I can now still change all of the tools. And if I change to the seeds, then this also works really, really well. Perfect. This looks good. Nearly done. The last thing that we have to add is going to be that we want to hide both containers once the timer times out. We have done that one before. We need this for a loop, like so. And then we are good to go. Final attempt. I can now change the tools and change to different seeds, and they should still disappear after 1 second. That works pretty well. Perfect. Now that we have the basics of the player, we can work on the environment, which is going to cover 3 parts. Most importantly, we're going to work on the plants. Besides that, I want to have some random bushes and stones, and finally, we will need the day-night cycle. For all 3 of those, we are going to learn a few more advanced concepts. And the first one that I want to work on is going to be for the random bushes. Those are being created via tools, which are a super handy concept in Godot. Effectively, they let you run code inside of the editor right away. Really helpful to get a preview of how things are going to look like inside of the game. And to get started with all of them, I want to close Tool UI and Tool UI Texture. We don't need them. Instead, I want to create a new scene where the root node is going to be a static body 2D, which I want to rename to, let's call this one, is simple object. Save the entire thing inside of scenes, and I guess we can put it inside of objects. Save it in there. And then, like for any other static body, we will need 2 more things. Something visible, in our case a sprite, and then a collision shape 2D. After we have that, for the sprite 2D, I want to go to graphics, and in there we have tile sets, from which I want to pick decoration.png. Drag it in there, and then if you zoom in, you can see a tile set with 8 graphics. 4 for the bushes and 4 for the stones. To pick the right one, I want to go to animation and then set 4 V-frames and 2 H-frames. That way, via the frame property, we can select one basically randomly. Let's for now use this graphic. It's a bit more visible. Besides that, we need a collision shape. So shape, let's go with a rectangle shape 2D. And for the size, I went with 10 by 4. I suppose we could add this right away to the level. So I want to add simple object, then drag it into the right place. Should still work just fine. That looks good. We have a small object that works inside of the level. So far, this was incredibly basic. Inside of simple object, make sure you have the right collision layers. We want to be on the terrain layer, and we don't need a mask. Now we can start with the actually interesting stuff. We want to turn this scene into a tool. That way, we can run code right inside of the editor. All you have to do for that is add a script to the simple object. The defaults here, as always, are perfectly fine. Let's say I want to rotate this object. For that, I want to have process and then rotate, for which we need some kind of value, let's say 5 times delta. Inside of the editor, nothing happened, but inside of the game, we are getting a rotation, as you would expect. This line is super basic. But what if you wanted a preview of this code inside of the editor? All the way at the top, you could add tool. Simply by having that. If I close the scene and reopen it, simple object, then you can see we have a rotation. This is also going to work inside of the level, and there you go. We can now run code inside of the editor. This is arguably not the best example, but you get the idea. Besides that, we could also do position.x plus 10 times delta, and this should be plus equal. Now, this graphic is going to the right, and this would also work inside of the editor. Also not something that you want to do, but you could make use of it. So the basic idea is, once you have add tool at the top, you can run code inside of the editor. Process is going to run on every single frame, and ready would be run when the scene is added. Let's actually work on that. And I do not want to continuously update the sprite. Instead, I want to run func_ready when the thing is ready. For now, let me add pass in there and then talk about it. And by the way, once you're using tool, you have to be careful because right now we have changed the code, but inside of the editor, this stuff is still running. If that is a problem, you can simply close the scene and reopen it, simple object, and then we haven't changed anything. If that happens to you, what you can also do inside of the code view, right-click on the script, and somewhere in there you have soft reload tool script. Now this thing is not moving anymore, and to replace it at the center, reopen the scene, and there you go. When you're working with tools, reopening the scenes and reloading the script is kind of a common thing that you are going to do. Using tools can be a bit finicky, so do be aware of that. Now that we have that, by default, we're getting this bush. And for that thing, I also don't want to have any rotation. That's better. Right now, we have this default bush graphic, which we are getting from this frame. That we can randomize once the scene is ready. All we have to do inside of ready is update sprite2d.frame. Since we know there are 8 frames in there, we can simply get a rand I range from 0 to 8. If I now run the game, we are getting a smaller bush. If I try it again, we're getting a stone. If I do it one more time, we are getting another kind of bush. This works pretty continuously. We always get a different graphic, and this is randomized. That's the basic idea of a tool. Via that, inside of the game, we can copy this object multiple times, and you can see every time I duplicate it, we are getting a random graphic. Looks pretty good. If I now run the game, we're getting a whole bunch of random stuff. And this we can push quite a bit further. I want to add export range, where we are going from 0 to 3 at a step size of 1. And the variable we are storing inside of size, which has to be an integer. With that, once we have simple object selected, we have a size that we can change. This size is going to determine the actual size of the object. Besides that, I want to export an enum, for which we can set 2 strings. I want to have bush and I want to have rock. The resulting value I want to store inside of a style variable. The data type for this one is also going to be an integer. If I now save the script and re-look at the simple object, we have a style, and there we can select bush or rock. Bush would get a value of integer 0, rock would get a 1. These 2 values we can then use inside of a sprite to update the frame coordinates. The x coordinate would be the size. If you change those, you get a smaller to a larger graphic. While on the y coordinate, you get either a bush or a rock. That way, we have more control over what we are getting instead of just getting a random frame. So let's get rid of this one. Instead, I want to work on sprite2d and update the frame coordinates. That is this value here. To that, I want to assign a vector to integer with the size for x and the style for y. At the moment, inside of simple object, we have 0 and let's go with bush, so we have the default values. Back inside of the level, you can see all of these graphics have been turned into a small bush, and this also still works inside of the level. Looks pretty good. However, I can select one of them and change the graphic to, let's say, 2 and rock. And then for this one, we're getting a rock. So right inside of the editor, we can change the look of this graphic and have more dynamic assets. And this different style you can even preview. For example, for the size, we can use set value to first of all update the size itself via size equal value. And besides that, we can rerun this line here, like so. And if I now save it and go into the editor, I can select this one here and change the size, and we get a live preview right inside of the editor. The same thing we can do for the style. Let me just copy all of this, because fundamentally, we are doing the same thing. We just want to, in this case, update the style. The other stuff can stay the same. And now, if I have this one selected, we can either have bush or rock along with the different sizes, and that is working super well. And that is pretty much it in terms of the basics of a tool. It's a super handy feature to run some code inside of the editor, and if you use set value, you can even get a preview right away. To finish this part, let's do an exercise. I want you to add a random bool value that should be exported. If this one is set to true, the simple object should be randomized. So the values for size and style will be ignored. Instead, we get something random. Pause the video now and see how far you get. Back inside of Godot, I want to export a var random, which is going to be a boolean. So if I save the script now and reselect simple object, we have random. This can be true or false. After we have that, inside of the ready function, if random is enabled, then I want to change size and style. For size, we want to have a rand_i range that goes from 0 to sprite2d.h frames -1. Whereas for style, we simply want to have a value that's either 0 or 1. We can create that in a couple of ways. I think the easiest one is an array that has 0 and 1, and then we call pick random. And that is pretty much it. If we now have random enabled, we are running this line. So before we are updating the frame coordinates, we're getting something random. To check all of that, let's say for this rock, I want to have a random enabled, run the script, and now this rock has become something else, but all of the graphics have become different. If you look closely, right now we have the two bushes here and we have a rock. Only the rock should be randomized. These two bushes should stay the same, but inside of the game, all three of them have been randomized. This kind of thing usually happens because the code here needs some time to update. Or to be a bit more specific, you want to get rid of all of the objects and then re-add them. Simple object, which I want to drag close to the player. Right now, we're getting size 2, rock, and random on, which means we should be getting a random graphic inside of the game. That works pretty well. Cool. If I disable random, we should always get the same rock. That looks good. Let's hope that wasn't luck. And yeah, cool. If we now have it disabled, we always get the same graphic. And if I change it to bush, the largest one, this also works reliably. If I now duplicate this graphic, move it here, and have this one being random, while this one is not, then we should get a better result, and that looks much better. We are always getting different graphics for this one, but not for this one. Once again, when you're working with tools, you do have to quite often reload a scene or re-add an object to a scene. It can be quite annoying, but once you have the system set up, it can be incredibly powerful. With that, we just have to add a few more minor parts, and then we are good to go. The first one that I want to add is a small demonstration in terms of what you can do, because there's one additional feature that I haven't covered yet. Inside of a tool, we have an export tool button, for which we need to have two arguments. The first is the name that we want to call. Let's call this one the randomize button. Besides that, we want to have an icon. This, you can see a preview here, gives you the kind of icon that is going to be next to the name. You could leave this one entirely empty. What I want to go with is called callable, so we get this icon. That's all that this argument does. After that, we need a variable that is going to store a function. which I'm going to call randomizer, and the function I want to assign to it is called randomize. This function we do not want to call, but we do have to create it. So func randomize. For now, let's simply print random stuff in here. Once you have that kind of setup with an export tool button, then if you have the simple object selected, you can press a button, and inside of output, at the moment, we're getting an error message that we're going to fix in just a second. But for now, inside of the inspector, we have a button along with an icon. A pretty cool feature. To get rid of the error message, you want to close the scene and reopen it, simple object. If you now click on random button a couple of times, and I should show the output, we now get random stuff right inside of the editor. So we have a button that can execute some code. For example, what we could be doing is get these two lines, paste them in there. That way we're getting a random size and a random style, which I also want to use right away to update all of this. Once we have that, I can press the button, and we are getting a different graphic every single time. I guess we should only call this randomize because we know it's a button, because, well, it is a button. But that's the fundamental idea. Via this export tool button, you can assign a function to a variable, and then Godot is going to execute it every time you're pressing the button. That's pretty much it. Although you do want to be careful. Sometimes when you have this export tool button and the set functions, then Godot is going to give you an error that this sprite2d doesn't exist because it wasn't initiated yet. Usually when you're reloading the scene or do the soft reload, this is going to fix it. So in my case, inside of the level, I should be able to randomize all of this just fine. Works pretty well. We're getting the expected result, but sometimes you get an error. If that happens, reload the scene, or if that doesn't fix it, simply comment out this line, and then you don't get a randomizer button. Tools sometimes can just be a bit unpredictable, so only use them when you have a good use case for them. Anyway, for the final bit, I want to implement a system that if a graphic is too small, let's say it looks like this, then there shouldn't be a collision, and the player should always be on top of it. Let's go with this one, then you can see it even better. The player should simply walk over the stone, and there shouldn't be a collision. And while we are doing that, I want to disable the randomize button and this function. You could keep it in there, but I want to keep it simple, and we don't need this part. I have to work on two things. Number one, I want to toggle collision shape and disabled. This one should be disabled if the size is smaller than 2. Which we can do by simply checking size smaller than 2, and then we are good to go. Inside of debug, I can enable visible collision shapes right inside of the game, and if I run the whole thing, you can see that we have a collision here for the bush, but not for the rock, so we can just walk over it. But now we can see the second issue, that the rock at the moment, because of Y sorting, is on top of the player. Not ideal. To fix that one, inside of the simple object, I want to update the Z index. This one is going to be -1 if size is smaller than 2, and else Z index 0. This at the moment means that the rock is not visible because it is below the tile set. To fix that, we have to work with the Z indexes of all of the tile sets. The water layer inside of ordering should be on Z index -2. It should always be behind everything else. The grass layer should also be on this layer, so ordering Z index -2. All of these layers should be on the Z index -2. So same for the soil water layer, -2. That way these are always behind everything else. Most of the objects then are going to be on Z index 0. But if we have a simple object that should be behind them, but on top of the tile sets, they're going to get a Z index of -1. So if I now run this thing, this rock is going to be below the player, and we do not have collisions. Whereas for the bush, we do have Y sorting, and we have collisions. That works pretty well. And that fundamentally is the concept of tool inside of Godot. The next part of the overworld is going to be a daytime transition. This will consist of two parts. Number one, we're going to indicate the current daytime via some lighting. So early on in the day, it's going to be more red-ish, and then towards the evening, it gets darker and bluer. Besides that, we can restart the day, for which we will add a transition shader and then reset the level, which for now only means that the apples are going to be respawning. Later on, we are also going to add the plants to it, but step by step. First of all, inside of Godot, I want to indicate the daytime via some colors. At the moment, we always have the exact same color. And for that, Godot has a nice node. It is called Canvas Modulate. What it does is it, modulates the canvas. By default, we have white. This one doesn't change anything. But if I change the color to, let's say, something bluish, then you get a really strong effect. Obviously, this is not what we are going to do. But if you change it just a bit, make the entire level, let's say, look a bit like this, we can make some changes to the lighting, and this works really, really well. Via that, we can indicate the time of day. Although for that, we need to do a few more things. And number one, I want to keep stuff organized, so I am going to add a node to B that I'm going to call overlay. In there, we have the canvas modulate node, and I'm going to rename it to daytime color. Besides that, for the actual length of the day, I want to add a timer, which is going to be inside of a node called timers. So in there, I want to have the actual timer. This will be the day length timer. The wait time of this timer is going to determine the length of the day. For now, let's say 20 seconds, and we do want to auto start. Also, this should be one shot. We are going to manually restart it. Now that we have that, we can work with daytime color quite a bit more. And the most important thing that we need are the actual colors that we want to use. That information I want to store in the level, so we have it more accessible. In there, for the script of the level, I want to export a variable. I want export var daytime color. The value that I want for this is going to be a gradient. Once you have that, with the level selected, we can create a daytime color. The only value that we can add in here is a gradient, and then we can set the actual colors. In my case, the start color should be the color value EDDCD0. A very light brownish color, I guess. On the other end of the spectrum, I want to have 5E77FF, which is a bluish color. And in the middle, if you simply click on it, then you can add more values, and I want to have a white color here and another white color here. This is going to be the morning, which is a bit more red. During the midday, we are getting the neutral color, and then the later it gets, the bluer the game will become. Once we have that, I want to, inside of func process, sample these colors using the timer. Or in other words, this day timer is going to determine the length of the day. So at 0, we would start the day. At 10 seconds, it would be midday. And at 20 seconds, it would be midnight, basically. This value we want to use to sample one of these colors. For which, first of all, I want to create a var daytime point. And just to demonstrate what we are getting, I want to get the day timer and then get time left. Let me print the value as well. Print daytime point, and we also don't need delta time. If I now run the game, inside of output, we can see the timer. It starts at 20 and then goes down to 0. So what I said earlier was slightly incorrect. At 20 seconds, we're starting the day, and at 0 seconds, we have midnight. At 10 seconds, we're still at midday because that is the midpoint. This one doesn't change. So how can we sample from this gradient using the daytime point? First of all, for that, we have to normalize this value. At the moment, it goes from 20 to 0, but this should be a value that goes from 0 to 1 at all times, regardless of the length of this wait time. That's quite easily done. All we have to do is to divide it by the wait time, or the duration of the timer itself. If you have this formula and you run the game, we are starting at 1 and then we are slowly going down to 0. Works pretty well, although I want this to go the other way, which we can achieve by simply doing 1 minus this value. That way we are going from 0 all the way to 1, and this is looking really, really good. With that, we have a point that we can use to sample from the gradient, which means next up we can get a var color, for which I want to get the daytime color, the gradient we have set earlier, and on there it's a bit deceptive. There is a get color value, but that's not what we want to do, because get color would get these dedicated values. You would add, if I added as an argument, an integer point. This would be 0, this would be 1, 2, and 3. But we don't want to get dedicated values. We want to get each individual gradient point, so we have as much detail as possible. GetColor doesn't do that, but sample does. In there, you can add a float, and this one is much more detailed. For that, we have our daytime point, which is giving us the color. So next up, we can get the daytime color, this color modulate node, and set the actual color, which for now is going to be the color that we are getting from this variable, and then we are good to go. And to really highlight the effect, for the day timer, I'm going to set the wait time to 5 seconds, a very, very short day. If I now run the entire thing, you can see that the colors do change quite drastically, and this worked super well. Perfect. Also, inside of debug, we don't need visible collision shapes. And there we go. We have a daytime color. If you set this wait time to a real value for a real game, let's say 180, so one day is 3 minutes long, which means right now the game is just a tiny bit more red, but very slowly is going to become whiter, and then very, very slowly is going to become bluer and darker. But other than that, that's pretty much it. It's a fairly simple effect. Besides that, for the overlay, when we are doing a day transition, I want to have an effect that is going to look like this. And for that, we can use a shader, which means I want to overlay at a canvas layer. That way, we're going to ignore the camera. As a child to it, I want to add a color rectangle. Because of this canvas layer, this color rectangle will be attached to the camera, so inside of the game, we are always going to have a small rectangle in the top left, which is almost correct. To change it, I want to click on the preset button and then cover the entire rectangle, while also changing the color to, let's say, a really darkish gray. Could also be black, it doesn't really matter. If I now run the game, you can see that we can't see anything. Perfect. Let's rename this to the day transition layer. And on there, we want to use a shader to create the actual transition effect, for which, instead of material, I want to add a new shader material, and then a new shader. I want to have a code-based shader that we can call the circle transition, which I also want to save inside of the shaders folder, shaders, and circle transition.gd shader. Once we have that, we can write a code-based shader. For all of that, we only need a fragment shader, so we can get rid of everything else. And fundamentally, we have to get a circle, which we can achieve by measuring the distance from every single pixel to the center point. I want to have float, circle, and then get the distance to a vector 2 at a position of 0.5. And then for the actual position of the fragment, I want to have the UV position. This is going to give us the circle, which we can then use to update the alpha value of the entire thing, like this. If a fragment is close to the center, then we are getting a very low alpha value because the distance from here to here is basically 0. But the further away we go, let's say to this point up here, we're getting a higher alpha value because this distance is quite a bit larger. That's all we are doing in here. Now to get rid of the gradient, you want to use the step function, for which you want to set an actual value and then a limit where you want to cut it off. Let's say for now 0.5. And then you can see we're getting a sharp edge, much nicer. This we can also animate via a uniform float progress, which is going to get a hint range of 0 to 1 without a step size. This progress we can use for the limit. Right now, this makes the entire thing black because the default value is 0. But if I go to shader parameters, I can animate this value, and this looks pretty good. I can also do all of this inside of the game, and this is giving us something. But you might notice the effect doesn't look great because this isn't a circle, it's an oval. That happens because our viewport, this entire thing, isn't a square, it's a rectangle that is wider than it's tall, and the shader is adjusting to that. As a consequence, we need to add a bit of math to reverse that effect. First of all, for that, I want to get the actual ratio that we are working with. So ratio, and I want to get this screen pixel size dot y divided by the screen pixel size dot x. That way I'm getting the aspect ratio of our screen, which I can then use to create a vector2 adjusted underscore center, where I want to create a new vector2 with x and y. Now y doesn't need to change. We simply want to get uv.y. But for x, I want to mix at the halfway point, so 0.5, the uv.x value and the ratio. Once we have this adjusted center, we can update this circle variable, where we want to go from vector 0.5, that is the actual center, to the adjusted uv, which at the moment isn't going to look great. But inside of the game, this works really well. Now we have a circle. I think a better name here, instead of adjusted center, would be adjusted UV. Like so, that just feels cleaner. Now in just a bit, we are going to animate this progress value using a tween. But before we can get to that, we have to add just one more thing. When I set this value to a 1, it doesn't entirely disappear. So if I run the game now, we still have a couple of corners that just don't look great. That happens because this progress is only going to 1. But to actually make them disappear, we have to go just a tiny bit further. You could make that work in two ways. Either you can set the hint range for the maximum value to 1.5, and then you can go just a bit further. Now they should have disappeared. And they did. That looks good. We can't see a black bar anymore. That being said, ideally for a shader, these shader parameters should always go from 0 to 1. It just feels easier to work with. As a consequence, I want to keep this value at 1.0 and instead do progress times 1.5. The end result is going to be the same, except now our progress value tops out at 1, which is, I think, a bit more predictable. And by the way, what you can also do is 1.5 minus this value. That way, progress being 0 clears the entire screen, and the progress value of 1 gives us the fully black screen. So this shader is at the maximum value at 1 and does nothing at 0, which I think feels a bit more reasonable. But work with whatever you prefer, just keep it consistent. Now we have to use it. That's going to happen inside of the level. I want to create a func day underscore restart. All that we want to do in here is create a var tween. So as always, create tween and then tween a property. And we want to get the day transition layer and target the material on it. The property we want to get is shader underscore parameter slash progress, or whatever you called this value. Then we need a target value 1.0 and a duration, which I have also set to 1.0. Now, since this is a bit hard to read, let me cut out this part and then below the player, onReady var day transition material, we're getting the overlay material. Make sure you're adding this material. That is really important. Then you can add this value in there, and that makes it a good bit more readable. I then want to duplicate the entire value and set the target value to 0. We are going to the full value, and then we're going back to the start value. Since this thing is running in sequence, that should work just fine, although I do want to add a pause in between, which we can do via tween interval. The duration of the pause should be half a second. With that, we should be getting something. But now we have to figure out how to trigger this one. For that, inside of project, project settings, and the input map, we have somewhere in there day change, which is just there for testing purposes. That way, by the press of a button, we can restart the day. But later on, we only want to restart the day when the player is interacting with the bed. But that's not an issue for now. Step by step, I guess. All we need for now, inside of process, is if input is action just pressed with day change. If that is the case, I want to day restart. That should do something. If I now press tab, we are getting the day restart. We can also do it multiple times. That looks pretty good. Perfect. There are two things that we need to do to actually restart the day. And let me demonstrate the first issue. If I set the day timer time, or the wait time to be a bit more specific, once again to 5 seconds, I can start the day, and after 5 seconds, it should become pretty dark, and it does. If I now restart the day, then we are still at night. So it doesn't feel like we restarted the day. That's the first thing. The second one is the tree should also reset all of the apples if the tree is still alive. I.e., if the tree was cut down, there shouldn't be any new apples. Would be weird if it did. For all of that, we are going to need another function, func level reset. For now, let me add pass in here, so Godot is not complaining. And this function we want to call in this spot, after the pause, but before revealing the level. That we can do via tween call back. This function wants to have a callable, which in our case is level reset. And just to demonstrate, I want to print level reset, run the entire thing. If I now press tab, we are getting level reset. Perfect. Number one in there, we have to get the day timer and then start it. Since we are dynamically sampling time from the timer, once we have restarted it, we are doing all of this from scratch, which should work already. Let's wait 5 seconds, then the entire level should become pretty dark. That looks good. And if I now restart the level, there we go. It is morning again, and we're going back to the darkness. Looks good. Another attempt, and once again, this works pretty well. With that, we have the proper date time. Besides that, we have to work on the tree. Let me open it. Tree. If this tree is still alive, then when the day is restarting, I want to create new apples. Or in other words, I want to get rid of all of the existing apples and then create new ones. For all of that, we can reuse the same functions. This part is going to be an exercise. I want you to reset the apple tree when the day restarts, which basically means if the tree is still alive, create new apples, and for all of that, reuse the existing functions. Pause the video now and see how far you get. Righty, let's work inside of the tree. And fundamentally, to keep the logic organized, I want to create a func reset, in which we're going to do two things. Most importantly, we want to create apples, the function that we have used up here. And to make this a bit more randomized, I want to have a rand_i range that goes from 0 to 2, which I guess we should also be doing up here. So we always get a random amount of apples. On top of that, we should be getting rid of all of the existing apples, which are just sprites that are inside of the apples node. For apple, in the apples node, get children After which we can apple and Q3. That's pretty much it in terms of the basics. But now we have to figure out how to call this function. And for all of that, we already have access to the tree via the group. Every tree is inside of the objects group that we can use inside of level reset. Most importantly, I want to get for object in get tree dot get nodes in group along with objects. After that, we can check if a reset function is in that object, and if that is the case, we want to call object.reset. That's pretty much it. If I now go to the tree and get one of the apples, the apple disappears, and if I restart the day, we have new apples on the tree. Although now the tree has disappeared, and if I restart the level, then we are not getting any more apples. Actually, we do. So this we have to work on. I suppose the easiest way of approaching that is to check if health is greater than 0. Only then do we want to do all of this. If I cut down the tree, I can restart the day, and we are never going to get any more apples. That being said, at the moment, when we are restarting the day, the health of the tree doesn't go back to 3, meaning the tree will definitely die at some point, which I don't think is ideal. So if the tree is still alive, then I want to reset health to 3. That way, we can harvest the tree basically indefinitely. Okay, right now, we didn't get any apples. There we get one. We just got unlucky. So now let's try it again. There we have another apple. And I can just keep on harvesting this tree. Unless we kill it, it is always going to bring back a couple more apples on the next day. Let's say I want to have a range of 0 to 3 apples. That's going to be a bit better. Yeah, this fits nicer. So now I can get some apples, and we are always having at least a few apples on every single tree. It is time to work on the plants, the key part of the game. We already have a basic plant scene, and this we want to expand. On top of that, I want to add a UI overlay that gives you all of the details of the plants, i.e. how far along they are in terms of their growth and their health, so for how long they have not been watered. And for all of this, we are going to learn about a really important concept in Godot called resources. Let's talk about that really quick. Inside of Godot, resources are just data containers. That's literally it. And even more basic, they are scripts without nodes. Incredibly simple. You have actually used them before. Godot has loads of inbuilt resources. Any animation, shape, curve, tileset, themes, and fonts are resources, meaning they contain data, but they are not a node. Here's our Godot project, and in just a bit, we want to work on plant.tscn. At the moment, this one doesn't do very much. We are simply setting up a plant, and then that's it. First of all though, we have a folder called resources. To that, we want to add the plant's resources. And if you right click, you can create new, and there you have a resource. If you click on that, you can see all of Godot's inbuilt resources. For example, there you have shape 3D, and below there we have shape 2D. All of these shapes are resources. And for the plant, we have literally used a capsule shape 2D. There are also loads of others, like for example, animations, and if you scroll down, you can see all of them. There are loads of them, and this is how Godot handles data. It doesn't necessarily need to be a node. That being said, why use a resource in the first place? For example, in our case, we could keep all of the logic for the plant inside of this scene and simply expand this script here to include all of the logic. That would be perfectly fine to do. The plant scene is really simple. Keeping the logic contained in there would be perfectly serviceable. Generally, it is quite easy to overuse resources and add needless complexity. You do want to be aware of that. Only use resources when they actually benefit you. Figuring out when that is needs a bit of experience. But I think generally a good use case is when you want to reuse data across multiple nodes. For example, imagine you want to make a Pokemon game where each Pokemon would have some data that you want to display in a couple of ways. And the data would include things like the health of the monster, the level, the name, the experience, the attacks, stuff like that. A good setup for that would be to have the monster data as a resource. And then you pass this data around to represent it as a sprite inside of a battle, as a texture rectangle inside of a Pokédex, and as a simple label inside of a menu. That way, you can keep all of the data inside of one place and simply paste it into other nodes. This kind of system we are also going to do for the plants, where we have a resource for the plant data, and this one contains the health of the plant and the growth status of the plant, along with a couple of other things. This we're going to represent inside of the plant itself, so you can see what we get, and inside of the UI overlay, where we show the plant data. That was quite a bit of theory. Let's implement all of this. Inside of Godot, we want to create a new resource. For that, inside of the resources folder, I want to create new, and I do not want to create a resource. Instead, I want to create a script. This script will then be turned into a resource. So click on this one. Now we need a name. I want to call this one the plant_res for resource. On top of that, this script should inherit from a resource. Make sure you're spelling this correctly. Godot should be giving you a green text. After you have that, click on create. And now nothing happens. But we do have a new GD script. This is, well, just a basic GD script. I guess the one special thing about it is that there's no node attached to this script. We simply have a GD script and that's it. Now the first thing that we have to do to make this usable is to give it a class name. Class_name. I want to call this the plant resource, and this needs to extend a normal resource. If you now save this script, you can go to resources, create new, and resource, and somewhere in there, if you look for it, you can find a plant resource, the thing that we have just created. That being said, if you create this one at the moment, it won't do anything because there's no logic inside of the script. Let's start with something basic. This plant resource should contain the texture of the plant. If you look at graphics, somewhere in there we have plants, and for each plant in there, we have a PNG file, if I drag this one in there, with the growth stage of the plant. This we have for corn, pumpkin, tomato, and wheat. And this texture we want to store inside of the resource, which means we want to export var texture. The data type for this one is going to be a texture 2D. Now that we have that, we can actually create one resource. Inside of the resources folder, I want to create a new resource with the plant resource. And now we have to give this one a name. Let's say for now, I want to create the tomato resource. Click on save. And now, inside of the inspector, we have the data for this resource. And since this is going to be the tomato resource, I want to go to graphics. There we have the plants. And I want to drag and drop tomato.png into the texture. Now, via this plant resource, we have the tomato texture. In turn then, when we are working with the plant, we want to add the texture to this plant, which we can do quite easily with the plant.gd script selected. I want to export var, let's just call it res, and this has to be of type plant resource. Once we have that, you could simply drag and drop tomato resource in there, and then we have the resource with the texture. This works very similar compared to creating a shape inside of a collision shape, because effectively it is the same principle. And alternatively, what you could also do is undo all of that and then simply create a new plant resource, and then in there you could add a texture to it. If you wanted to create a different plant from the plants folder, you could, for example, add wheat.png, and then you get a different texture. That is literally the entire idea of a resource. Inside of the plant, we now have a resource that stores all of the data for the plant, while the plant scene itself is going to become a shell that displays the information of the resource. So now, how can we actually use that? At the moment, when we are setting up the entire scene, we are updating the position and then pretty much not do anything else. But what we now are able to do for the sprite 2D, we can assign it a new texture that we are getting from resource, and in there we have the texture, the one that we have just created. So in this case, we would be getting a wheat texture. If I now run the game, let me plan something really quick. We are getting a wheat plant, and if I change the texture to, let's say, a pumpkin one, this one looks quite a bit different. I can run the whole thing again, and now we are getting a different plant. Everything else still works just fine. I hope so far the system makes sense. We are simply creating a data container with all of the inherent details of the plant. With that part covered, I now want to create a single plant, let's say for the pumpkin, that is going to grow and can be collected all from within the resource. For that, we will need two more things. Number one, I want to export another variable, which is going to be the grow speed, which is going to be a float, let's say with a default value of 0.5. Or well, I guess for testing purposes, let's say 1, so the plant grows a bit faster. Besides that, I want to have a normal variable that is going to be the h, which for now is going to be a float. That's all we need for the basic data of the plant. After we have that, when the day changes, we want to track if this plant was watered or not. And just to demonstrate, inside of the game, I can plant a plant and I can water it, but when I change the day, that doesn't really do anything. So we have to update our date change function just a bit. Or in other words, I want to work inside of level reset. I want to check via a for loop for plant in get tree along with get nodes in group plants, which we might not have yet. So each plant needs to be inside of a group called plants. That way we have access to all of them. After that, inside of this for loop, I want to call plant.grow. But this should only happen if the plant was watered. If it wasn't watered, then we want to do something else. That's going to come later. We now have to check if this plant was overlapping with one of the soil water layer tiles. Remember, via those, we are adding the water tile to the soil. To get that, remember, inside of a plant, we are storing the coordinate. That's why we know where the plant is inside of the level. And since this is tracking with all of the tile sets, we can do plant coordinate in the soil water layer get used cells. That way you know if there's water on this tile or not. This function we now need to create inside of the plant. And just to be clear, right now we are inside of the plant. We are not in the plant resource. Inside of this for loop, we are targeting the plant, not the resource. So in here, func, grow, and then the one parameter is going to be watered, a boolean. If watered is the case, then I want to call resource.grow, which in turn is going to go inside of the plant resource. So now in here, we also get a grow function, in which we are updating the age of the plant, which is very simply going to be age plus equal grow speed. That way, we're keeping track of the age of the plant. On top of that, what we can do, when we are calling this grow function, we can pass in the sprite to the one that actually shows the plant as an argument into the function, for which we are going to need a parameter. So I want to have a sprite, which needs to be a sprite t. Because now that we have access to the sprite, we can update the frame. So we are going to show a different kind of plant. All we have to do is sprite.frame frame is going to be the integer of the current age. And this should already do something. Let's try. I want to plant 2 plants, like so, and then only water one of them. Let's say the left one, like so. And if I now restart the day, the left plant has grown. And if I restart the day again, it's going to keep on growing, while the right one does not. Although you got to be careful, at some point we are going to get an error message, which doesn't crash the game, but if you look at the debugger, we're getting 2 error messages. That at the moment, the pframe4 is out of bounds for this sprite. The sprite has 4 frames and the age exceeds that number. To fix that one, I want to assign the minimum value of age plus grow speed or sprite.ageFrames. That way, we can only grow up to the maximum number of frames for the sprite, which for all of the plants is going to be 4. We always start at 0, then we go to 1, 2, and 3. Although, you gotta be careful once again, because age frames is 4, but the maximum number is 3. As a consequence, this should be age frames minus 1. If you want to keep things simple, since our data is pretty consistent, you could also add a 3 in here and call it a day, but this system is a bit more flexible. And just to test things, let me plant something really quick, and now restart the day a couple of times. Now we have the final plant, and if I restart the day, nothing should change. And that looks pretty good. Cool. With that, we can create basic plants. And all of that is stored inside of a resource, whereas the plant itself is simply going to be a static body 2D, a sprite, and a collision shape that doesn't actually do very much. And to practice all of this, let's do an exercise. I want you to add a depth counter to the plant via the resource. If the plant has not been watered for 3 days, it should disappear. For that system to work, you also, on each new day, have to remove the watered tiles. That way you need to water the plant every single day. Pause the video now and see how far you get. Let's start with the most important part, inside of the level. After we have grown the plants, we want to get rid of the soil water layer tiles. All we need is the soil water layer and clear it. If I now run the game again and I plant something and then water it, on the next day it should have grown and the water has disappeared. So if I now restart the day, this plant is not going to change. Looks pretty good. Perfect. That's the first part. Besides that, we want to check if a plant was not watered, for which we can reuse the grow function, because in there we are checking if the plant was watered at the moment, so else means it wasn't watered. If that is the case, I want to call res and decay, which we have to create inside of the resource, decay. Fundamentally in here, I want to do something like def count plus equal 1. This def count doesn't exist at the moment, so var def count is going to be an integer starting at 0. After we have updated this value, I want to check if def count is greater than 2, or let's say greater or equal to 3, a bit clearer, then we want to remove the plant itself. So plant.q_3. However, this is not going to work because we don't have access to the plant. But we can get that via the parameters, plant, and this needs to be a static body 2D, because all we want to do inside of plant.gd, when we're calling decay, I want to pass in self. That way, we are passing the plant into the resource, and after we are exceeding this number, the plant is going to be deleted. Let's try. If I now plant something, I can restart the day. This is going to be 1, 2, and 3. And the plant has disappeared. Cool, this works. I suppose to be really nice, when we are growing the plant, so when the plant has been watered once, we can reset the dev count to 0. Makes the game just a bit more forgiving. With that, we have basic resources. In the next part, we can expand the system to make it much more flexible. Now that we have the basic plans, we have to make the system more flexible so that we can dynamically create different kinds of plans inside of the game. The basic trick to make that work is to create the resources dynamically from a database inside of our game. Here we are back inside of the game, and if you look at the data.gd script, there we have plant data, in which we have a dictionary where the key is the enum for the seed, like tomato, corn, pumpkin, and wheat. The associated values are a path to the texture, an icon texture that's going to be important for the UI, name, and the grow speed, along with the amount of H-frames and the dev maximum, so those values can also be more flexible. Although I think in practice I always kept them the same, but you could customize those as well. This data we want to use to create a resource dynamically. At the moment, we have created a resource by simply creating a resource in here via the drag down menu. So plant resource, and then whatever you want to add to it, like tomato, for example. Creating resources works like any other node. We want to do that inside of the level. When we are using a tool, we are checking for the seed. In there, we have to add just a bit more logic. Before we are creating a plant, I want to create a var plant resource, which we can create by simply doing plant resource dot view. That way, we have a new plant resource, and now this plant resource is going to need some data, for which we can do a plant underscore resource dot setup function. For that, we want to target this dictionary, or more specifically, the values inside of it, which means we have to get the current seed of the player. If you look at the player, there we have a current seed with the same enum, and this we are toggling inside of this if statement. As a consequence, inside of level.gd, when we are setting up the plant, we only need this one enum that we can get from, I think we have the player already, we do not. But we can drag and drop the node. So player, like so. And in there, we want to get the current seed. That way, we can set up the resource. After that, we have the plant, and we are calling a plant setup function. This setup is for the plant itself, so the shell, and this setup is for the resource, so the actual data. As an argument to the plant itself, I want to add plant resource. And before we can run the script now, we have to set up this plant resource.setup function. Inside of plant res, we now need a func setup. The one parameter is going to be the seed enum, which always has to be enum.seed. And now we simply have to go through this dictionary and assign all of these values to the resource itself. For example, the texture is going to be data.plant data with the seed enum, and then we want to get the texture. Also, very important, we want to load the entire thing. At least for now, the other things that we want to get is the grow speed, which is grow speed inside of that dictionary as well. Although this one we don't have to load, simply the data is fine. I suppose just to use all of the data, we can also add H-frames and dev max. For that, inside of the dictionary, I want to export var H underscore frames. So the amount of H-frames inside of the texture, this should be an integer, let's say with a default value of 3, and then export var dev underscore max, also an integer with the value of 3 as well. Both of these values we want to get from data, so H-frames and dev max. Copy this value, we want to get H-frames via h frames. And then we also want to get def max via the same principle. Double check that you always have the right keys inside of the dictionary. Looks pretty good. And to actually use them, h-frames is going to be what we're getting here instead of the sprite. And def max is going to be what we are checking here, def max. That way, you can customize the system quite a bit more. That's pretty much it. Once we have that, when we are using a tool along with the seed, then we are creating a new plant resource, and we're adding this resource to the plant. As a consequence, we should be getting the right plant. Let's try. I want to plant a plant, and we are getting an error message that the setup function inside of the plant doesn't have the parameter for this plant resource. That does make sense. Inside of the plant, for setup, we need one more parameter, the new resource, which needs to be a plant resource, which we want to assign to the resource. So res is going to be new res. Next attempt. Once again, I want to plant something, and we are getting one plant. If I now go to a different plant, this does not work. We are always getting the same kind of plant, and this shouldn't happen. Let's investigate. I think the issue is inside of the plant, we are setting up a tomato resource. And this, I think, overrides the resource that we're getting from the setup function. So let's not have a default value in there. Next attempt, if I now plant something, the game crashes. And there I realized what might be the bigger issue. We are first assigning a texture to the sprite 2D, and then we are creating the new resource. As a consequence, this resource can't get the data. This has to be the other way around. We first want to get the resource, and then we are creating the sprite. If I now plant something, we're getting one plant, then we're getting a different one. Let's hope this keeps on working, and this looks pretty good. Now we're getting 4 different plants. They should all have 4 different growth speeds, because inside of data, for every single plant, we have a different kind of speed for how fast this thing is growing. And also, while we're testing all of this, the day is way too short. I want to set this to 20 seconds, so it's a bit less distracting. Other than that, this is kind of all we need to create a custom resource from a database. So inside of data, we are now using all of this. Fundamentally, inside of Godot, you can very easily create new resources or nodes by simply writing the name of what you want to create, like a sprite 2D, and then .new. Then you have a sprite 2D, and you can update the properties of that node. We are doing pretty much the same thing down here, except we are assigning all of the values via a database. That way, you can have the data inside of a nice dictionary and change the behavior of the game in a very easy to understand way. Okay, with that, we can create different kinds of plants. Although I should test the entire thing. So let me create 2 plants, this one, and I also want to water them. Now, if we restart the day, one of them should grow a bit faster than the other. That looks pretty good. Although the left one should also be growing, at the moment it is not. Okay, this one is working, the other one is not. Something is going wrong here. This could actually be a pretty good exercise to figure out what went wrong. So we have one of the plants growing just fine, but the other one doesn't. What could cause the issue? And just as a tip, this is caused by a wrong data type. Just think about it for a couple of seconds and maybe investigate. The issue is, inside of the plant resource, we have set the grow speed to 1. This is going to give us an integer. But when we have the data for all of the plant speed, we are getting a grow speed that is a floating point value, which the plant resource then converts to an integer, And if this value isn't a 1, it's going to be rounded down. As a consequence, the growth speed is always going to be 0. This we can fix super easily by simply setting this to 1.0, or if you want to be super specific, this should be a float with a value of 1.0. Now this should be working much better. Once again, I want to plant something, let's say this one and this one. And if I now water the entire thing, I can restart the day, and both should be growing eventually. That looks good. Now we have growing plants. Much better. Next up, when the plant is fully grown and the player is in contact with it, then the plant should disappear, and later on, the player should get some resources. This can actually be a good exercise. Collect the plant when it is fully grown. That is going to be a couple of parts. Number 1, check if the player is close to the plant and the plant has reached the max age. The first part will be done inside of the plant, the second one inside of the resource. If both of those are the case, the plant should disappear. Pause the video now and see how far you get. I want to check if the player is close to the plant. For that, we need an area 2D that I want to call the collision area. In there, we will need a collision shape 2D, and to the shape, we want to add a resource, which is going to be a circle shape. Besides that, for collision, we don't want to be on any layer. The only thing that we want to do is to detect the player, which is on layer 2, so mask 2. On top of that, we want to connect the signal with body entered. Connect it to the plant. Then we have a function in which we don't need the body because there's only one option here, the player. If that is the case, I want to check if res.get_complete. If that is the case, for now, I simply want to call Q3. So next up, we have to get complete. That happens inside of the resource, in which we want to check func get complete. The only thing that we have to do in here is return the age being greater or equal to the age frames property. And that is literally it. Now to test all of this inside of the level, I don't want to, instead of level reset, clear the soil water layers. That way the plants are always watered once we have done it once. So let me plant something and water it. Now I can restart the day very easily. The plant should be growing after a couple of days. And I think I've picked the slowest growing plant. But there we go. We have a tomato plant that is fully grown. If I now get in contact with it, it disappears. If I plant something else, let's say a pumpkin, if I collide with this one, nothing happens. So this is working. Perfect. Now before we finish this part, I want to make the plants look just a bit nicer. For which, inside of the plant, I want to get rid of this sprite 2D and instead add the flash sprite 2D. We have used this one before for the blob and for the tree. All this one is doing is via a shader, we can make it flash white, like so, which we also want to do for the plant. Or in other words, when the player is collecting the plant, I want to make the plant flash for a short amount of time, and only after that part is done, it should disappear. Also, we have to replace sprite 2D with the flash sprite here and here. That way, we're getting the right sprite. Just to test if this is working so far, let me plant something. And there you can see, not ideal yet. What we have to do, instead of flash sprite, under animation, is set the H frames, which is going to be 4. And then, next attempt, much better. I think in the sprite 2D, what we also did under transform is set the Y transform to -9. That way, the plant is closer to the player. That feels better. Now we have a sprite that can be flashed. which we want to do if this if statement triggers. Basically, that means instead of Q3, I want to do something like flash sprite 2D dot flash. That is the function we have created here, where we have a start duration and an end duration. For both of those, we can add some values, let's say 0.2 and 0.4. This should do something already. Once again, let me plant something that grows a bit faster. I can water it. Now restart the day a couple of times. There we go. Now it's fully grown. And if I get in contact with it, we have a flash effect, which does work, but we are not getting rid of the plant. Which unfortunately, we cannot do like this. We can't simply call Q3 right after. You wouldn't see the flash because the plant gets deleted right away. Instead, we want to call Q3 after this effect is done. And the easiest way of doing that is to add Q3, the function, without calling it, very important, inside of this flash sprite 2D. What we can then do, inside of flash sprite, we can add a callback function, which needs to be a callable. And for a default value, we can add callable, which you do want to call, like so. That way, you're getting a default value. Because of that, we don't have to change any of the existing functions. They simply get a function that doesn't do anything. And now, what we can do. After we have done the start duration stuff, the first part of the tween, we can check if callback function dot is valid. This is going to check if we have a valid function, which this callable is not. However, Q3 is. If that is the case, we want to get tween callback along with the callback function. And then we're going to call this function between the two tweens. Next attempt, let me plant something really quick. And then water it and restart the day. Now, after a couple of days, I can collect it and it disappears with a flash. Finally, I want to re-enable this line. So we're getting rid of the soil water layer. And with that, we have the basic plants. All of which we are using a resource. And this resource in the next part, we are going to use for an overlay that displays the data for every single plant. Let's use the plant resources for an info panel container thingy. That way, for every single plant, we can tell what plant we have, how far along it is, so for how many days it has been growing, and for how many days it hasn't been watered. For the entire thing, we are also going to use a theme. That way, later on, we can reuse the styling or other UI elements. Before we get to all of that though, I want to work right away in Godot, and we have to create a simple UI container. The root node for this one is going to be a panel container. As a child to that, I want to add an HBox container. And let me zoom in. Here's a picture of how the final thing is going to look like. On the left side, we want to have a picture. And on the right side, we want to have a label along with 2 progress bars. And for that, we're getting the HBox container. As a child to that, I want to add a texture rectangle. That's going to be the icon for the plant. And then I want to have a VBox container, which is going to contain 3 elements. Number 1, a label. And number 2 and 3, a texture progress bar. 2 of those we need. And let's name things properly. This is going to be the icon texture. Label can just be the name label. Texture progress bar 1 is the growth bar. Texture progress bar 2 is going to be the depth bar. The root node is going to be called, I call this one the plant info. Save the entire thing inside of scenes and UI, click on save, and now we can add some items to it. First of all, for the icon texture. And by the way, later on, all of this is going to be dynamic. I just want to have some default stuff in here. For the icon texture, you want to go to Icons and then pick one of the plant icons. Like, for example, let's go with tomato. Drag this one into the texture, and now you get a horrible result. To make this one better, expand mode should keep the size, but for the stretch mode, we want to keep the aspect ratio centered. On top of that, under layout, I want to set a custom minimum size of 40 pixels. That is going to make the entire thing really large, but that's okay. Once we add more to it, it is going to look nicer. Speaking of which, for the name label, let's call this one tomato. Then for the growth bar and for the depth bar, we will need textures. For both of those, inside of UI, I have a vbar.png. Drag those into under and progress. That way, we are getting a basic bar that you could animate. And really important for them, you want to have 9-patch stretch enabled. That way, you are stretching this texture to cover the entire available space. Although for this to work properly, we have to set a custom minimum size inside of layout. For the Y value, I went with 6 pixels. Besides that, for the colors, at the moment, all of the textures are pure white, which is intentional. That way, you can tint them and get pretty much any color. For example, for the under color, I want to have a value of 171717, which is a darkish gray. If you now change the value to something larger, you get a nice looking indicator that you can also customize. The progress tint color, in my case, is going to be 8F D6 2F. After that, for the depth bar, we want to do pretty much the same thing. Under textures, I want to have the V bar in under and progress. By the way, we don't need over, this one would just be decoration. After that, inside of layout, I want to have a custom minimum size of 6 pixels. And we have to have 9-patch stretch enabled. For the tint colors, the under color should be the same as the background here. For progress, I went with C644 1D. And then if you increase the value, you get a nice looking reddish color. And that would be a very basic setup that we do have to refine, but for now, I want to implement the functionality first. Meaning we have to figure out how to create multiple of these plant info containers and display them inside of the level on the left side of the screen. For that, in my case, I want to create another user interface scene that I called plant info container. Save the entire thing inside of the UI folder, that's totally fine. To that, we want to add a margin container, then a scroll container, and finally a VBox container. The margin container is going to give us a bit of margins, so we have a more spacious layout. The scroll container is going to allow us to scroll, and the VBox container is the actual thing that holds all of the plant info bits. That being said, we do have to work on the sizing first of all, but I guess what we can do, as a child to the VBox container, we can add plant info, which at the moment gives us not an amazing result. First of all, for the margin container, this thing should cover the left side of the screen, vaguely this bit here. We can go to the presets and cover this button, after which, inside of the layout, we can give it a custom minimum size of 200 pixels. And besides that, inside of theme overrides, under constants, I want to give it a margin left and top of 10 pixels. You can already see we have a bit of space here and here now. Next up, we have the scroll container, and this one simply needs to take up the entire available space, which it does. After that, we have the VBox container, and this one needs to take up as much space as possible, and then we are getting something. And now, inside of plant info, if you save the scene, then this one should update and we get the right bit of information. Much better. And to display all of this inside of the level, we want to attach it to the canvas layer inside of the overlay. Simply add, I called this one the plant info container. And now, if I run the game, we should be seeing something in the top left. definitely looks good. That being said, the entire thing looks pretty horrendous, so we want to style it. For that, inside of plant info, in the root node, we want to attach a theme. Or in fact, first of all, we want to create a theme, which I want to save right away. So save as, I want to have a game theme. And now, inside of this game theme, we can set a style for every single element. For example, if you click on this button, the plus symbol here, you can define a style for every single label. Add the type, and now you get all of the options. For example, what you could be doing is change the font color to whatever you want. You can see an update here and here inside of the preview. I want the text color to be 060606, a very darkish gray. Besides that, for the font, I want to add a custom font. And if you look at the file system, somewhere in there, we are going to have a font folder. And I do want to use Home Video Regular TTF. But I do want to customize it. And for that, if I expand this thing just a bit, if you click on this arrow, you can create just a font file, but you can also create a font variation. That allows you to customize the font that you are loading. Click on that one, and now we can still select the font. Home Video, in my case. Then you can see we are getting something that happens because the font size is too small. That we can change here by setting the font size to 30. Much better. But besides that, back inside of the font variation, if you want to have more spacing between the letters, you can go to extra spacing and then under glyph, simply increase this value to whatever you want. I like 1 pixel, that just feels a bit nicer. That is giving us the text. Next up, I do want to customize the panel container. That at the moment is the root node. And by the way, I should mention, when you have a theme attached to a root node, it affects all of the children. Because of that, the theme inside of plant info is affecting this label. If you want to recap on UI elements in Godot, check out this video on YouTube. It covers all of the UI stuff in Godot in a lot of detail. For the panel container, I want to go to this icon here, where we can set the background styling thingy. I want to create a new one, and then create a style box texture, which at the moment hides everything. Because when you click on it, to see something, we have to set a texture, which I am getting from UI. There we have frame.png. Drag this one in there, and then we are getting something. At the moment, this graphic is way too stretched, which we don't want. To get rid of that, you want to set texture margins that cover the corners. In my case, 6 pixels on every side, and that is making a substantial difference. Let's try the entire thing now inside of the game. And I think that is looking respectable, it's readable, and it looks good. Which means at this point, we have to figure out how to create one of these things dynamically. That is actually going to happen inside of the level. Specifically, when we are creating, or when we are using a seed and we are creating a plant, then I also want to create one of those plant info containers, for which, all the way at the top, I want to have a var, let's call it a plant info scene, that we want to preload like we have done before. Plant info.tscn. This is the scene that we want to create. Every time we are using a seed, which we can do below everything else. Var plant underscore info is going to be the plant info scene.instantiate. After that, I want to do 2 more things. Number 1, plant info dot setup along with the plant resource that we have created up here. That way, we are referencing the same object in 2 different places. Meaning the plant is going to get all of the data from this resource, and so is this plant info container. And besides that, I also want to get the plant info container and add child with the plant info. Now, just to test things, let me comment out this line. And then whenever we are planting something, we should get another container which is not quite working yet. The issue at the moment is that we do have the plant info container, which is all of this. And at the moment, we are adding the node to this root node, which isn't correct. The plant info container should be a child of the vbox container. You could fix that in a number of ways. I think the easiest one is to give this plant info container a script and then add a function called add along with a child, which has to be a panel container. And all we want to do is to get the vbox container and then add child with the child that we are getting from the parameter. That is all we need. After that, back inside of the level, instead of add child, we simply want to call add along with the plant info. Next attempt. If I now plant something, we are getting more and more resources. Looks good. That being said, at the moment, this information is entirely static, and that we have to change, which will be an exercise. I want you to give the plant info panel the right information. The easy part is going to be the name and the icon. This you should be doing at the minimum. And if you want to have more of a challenge, also update the progress bars when the date changes. Pause the video now and see how far you get. Since we need some logic, the plant info scene is going to need a script with all of the defaults, and then I want to create a func setup. This setup is going to be called inside of a level on this line here, which means we will also need a parameter to capture the plant resource. Inside of the plant info GD script, we want to have, let's call it new resource, which once again has to be a plant resource, which we do want to store inside of the scene. So var res is also going to be a plant resource, and then res is going to be new res. Besides that, the way you want to think about it, now that we have access to the resource, we have access to all of these variables, which in turn are going to be populated from this dictionary. So in here, we can get the texture and the name of the plant. As a consequence, inside of the plant resource, we want to have two more variables, which I do want to export to keep the entire thing more flexible. So if you want to create a custom resource, you could do it. We want to have a name that's going to be a string. And besides that, export var icon underscore texture, which is going to be a texture 2D. And I'm going to move it up here so the two textures are together, but that's not really necessary. It just feels nicer. Now that we can store these 2 bits of information inside of the setup function, I want to get the name from data plant data seed enum, and I think this one was called name. Quick double check, there we have the name. Besides that, we want to have the icon texture, so in plant resource, we can duplicate this line and update the icon texture. Make sure you get the right key inside of the dictionary, should look like this. Then we have all of the necessary information inside of the resource, which in turn then we can use in the plant info.gd script scene, where we are updating this panel, because now inside of the resource, we have a name and an icon texture. For now, just to test things, let's update the name label. Drag and drop it in there. We want to update the text of this thing. And the info that we need is inside of the resource. And it is called name. Now, before we start, I do want to remove from the plant info container the one starting bit, because that's not needed anymore. Delete. And now, if I plant something, we're getting tomato. If I go to a different seed, we're getting corn and pumpkin, and then also wheat. Looks good. Good start. Next up, I also want to get the icon texture dot texture. which we also have inside of the resource. This one is called icon texture. Let's try a pumpkin. That works. And a wheat bit. That also works. Perfect. We have the two most basic bits. And I hope this system hasn't become too complex. Inside of the plant resource, we are storing the dynamic data for the plant. So in there, we have the age of the plant and for how many days it wasn't watered. Besides that, we have a name, a growth speed, and a couple of textures, along with a few more things. All of this data we are using in two places. Inside of the plant and inside of this container. And the resource itself gets lots of this data from this data dictionary. Definitely go over it a couple of times yourself. The system is getting a bit more complex. Other than that, inside of the plant info GD script, we have to do a bit more because we want to get the progress bars on day change. There are two progress bars that we have to work with. And for both of them, we have to update two bits of information. Number one is the value itself, where we are on this bar. And besides that, we also have to change the max value. Let's start with the growth bar. First of all, in there, I want to set the max value, which we are getting from the resource once again. And the value I want is the age frames. This one effectively is the maximum age. This we can then duplicate, because next up, we want to update the value. This is going to be the actual age of the plant. And by default, this one should be 0. Once again, if I plant something, we are getting a completely empty green bar. What we now want to do, when the date changes, we want to update this value. For which, we simply need a func update and then run the same line again. How can we trigger this update value? And I guess there are a couple of ways to do it. Number one, you could assign all of these plant info containers to a group and then loop over them using a for loop. Would be possible, but I think a cleaner way would be, since we know all of these containers are inside of this VBox container, we can give the plant info container a script where we can create a function update all in which we simply loop over this VBox container via for plant underscore info in the VBox container dot get underscore children and then child dot update. Actually plant info dot update. That way we have one function to update all of the plant info containers, which in turn we want to call inside of the level. Because when we have the level reset, I want to get the plant info container and call update underscore all. That should work. Let's try. If I now plant something and I water it, I can restart the day and we get a slight improvement. If I do it again, then we're getting a larger plant. So this is working, and let me just water it a couple of times. When the plant is fully grown, we should have a full green bar. And there we go, this worked. At the moment, once we collect the plant, nothing is going to happen, but that we work on later. For now, I want to also add the def bar inside of the update mechanic, which is very easily done. Inside of the setup function, I want to get the def bar and set the max value, which is going to be res and def max. After that, we want to update the value with the current def count. And by the way, really important, when you're updating a progress bar, you always want to first set up the max value and then the actual value. If you do it the other way around, you're getting some weird behavior. Be careful about that. Other than that, we want to duplicate this line and then call it inside of the update method. If I now once again create a plant. Right now, the red bar is entirely empty. And if I restart the day without watering the plant, you can see this value has increased by 1. Now it's even larger. And now the plant has disappeared. Works pretty well. Also, I realized we can make this entire system just a bit more streamlined. Since these two lines here are repeated, we can simply get rid of this line, and then call the update function. The end result is going to be the same. And just to test things, I want to plant something, and if I now water it, we're getting the green bar. If I restart the day, we're getting the red bar. And I guess I can water it again. Now, the red bar has disappeared, and the green bar should be growing. That looks good. Cool. That is pretty much all we need for the basic mechanic of the plant info container. There are 2 more things that we have to implement. Number 1, this plant info container shouldn't always be visible, so we can toggle it on and off. Besides that, when a plant has disappeared, this panel should also disappear. That's going to be the second part, and let's go through it step by step. Number 1, I want to toggle the visibility of this plant info container. For that, if you look at project settings, and the input map, I think all the way at the bottom, we have diagnose. The hotkey for that is the N key on the keyboard. I use that letter because building is M, and it's nice to have these 2 together. Which means we have to check for this button being pressed. You could do that either inside of the level script itself, or inside of the player script, which I prefer since we have all of the basic input in there anyway, so it kind of fits. I want to check if input is action just pressed, and this one was called diagnose. If that is the case, I want to diagnose.emit, which is a signal that doesn't currently exist. So signal diagnose without any parameters. After we have that, inside of the level, I want to get the player itself and then connect the diagnose signal. Connect, after which we have a function on player diagnose, which I want to move up so we have all of the player stuff right next to each other. Should be below on player tool use. This isn't necessary, it's just nice to have all of the player stuff in one place. If that is the case, we want to get the plant info container and update the visible property. This should be the opposite of the current state. If the container is visible, it should become invisible. If it is invisible, it should become visible. That you achieve by simply assigning it the opposite, so not, of the current value. So I want to duplicate this line, and that is all we need. Inside of the game now, I have to plant something. There we go. And if I now press the N key, we are toggling the visibility. Cool, that part was easy. Next up, when a plant has been destroyed, so either if it has died or if it was collected, then I also want to get rid of this plant info container. I want to work inside of the plant and give it a signal called def, which is going to get 1 parameter, the coordinate vector to integer. I actually forgot to mention, when a plant dies, we have to do 2 things. Number 1, get rid of this plant info container. And number 2, inside of a level, we have to get rid of the used cell inside of the used cells array. Without that, we couldn't create a new plant in this spot. When the plant is fully grown and the player collides with it, then I want to def.emit along with the coordinate, so its current position, that we're getting from this variable. Now, with that, we can emit a signal when the plant is dying. But first of all, we have to connect this signal. And for that, we are going to do a slightly more advanced functionality. We're going to pass a function from the level into the setup function and then call it via the signal. Let me demonstrate. Inside of the level where we have all of this stuff, I want to create another function called func_plant_def, for which we want to have one parameter, the coordinate, a vector to integer, that we want to remove from this used cells array. That part is super simple. Used cells dot erase with the coordinate. And this is the function that we want to call from within the plant when the def signal triggers. To do that, when we are creating a plant, inside of this plant setup function, I want to add the function itself, so plant def, without calling it. That way, we are passing a function into this setup function here, which we do have to capture via a parameter plant def function. And after we have that, I want to connect the def signal via connect. And then we need a callable, which is the plant def function. Just to test this one, when we are creating a plant and updating the used cells, I want to print the used cells. And on top of that, when we are calling plant def, I want to do the same thing. If I plant, I think corn is growing the fastest, I can water it, restart the day, and do this a couple of times. Nearly done. Now, if I collect this plant, we are getting an empty array. So this worked really well. Being able to pass functions around is incredibly helpful. Definitely something that you want to practice. Fundamentally, inside of the plant, when you're connecting a signal, the signal doesn't care where the function is coming from or where it lives. As a consequence, you can get the function from literally anywhere inside of your game. Getting used to this kind of system gives you a lot more flexibility in terms of your game design. Speaking of which, we're going to learn another way to make stuff more flexible. When we are running this function, I also want to get the resource and then update a dead variable, which doesn't exist yet. We'll fix that in just a second, but for now, I want to set it to true. If that is the case, for that, inside of the plant resource, we will need var dead, a Boolean value. And this value we want to monitor via set value, in which we are updating the dead variable in the usual way, like this. Besides that, what we can do is call emit changed. This is a signal that we can capture in any scene that is connected to this resource. For example, inside of the plant info scene, where we are displaying all of the information, we can get resource and then connect it to a changed signal. This will be triggered every time inside of the resource when we are calling emit changed. And for the second argument, we can call basically any function that we want, which in my case is, I call this one a def checker. Make sure you're not calling it, but you do want to create a def checker. And all we want to do in here is Q3. That way, once again, let me create a different plant. This time, I just want to water it a couple of times. This one is still growing. Now we can collect this plant, and the plant resource has disappeared. One more thing that we have to do. This emit changed needs to be called when the plant has decayed. So in here, emit changed, and now if I plant something and restart the day, then after 3 days, both the plant and the info panel should disappear, and they do. That looks good. With that, we can use resources quite well, and this emit changed is super useful. Via that, you can track if any of the variables change, and in all of the scenes that use it, you can do stuff with it. Makes it much easier to communicate between the scenes and the resource. And one thing that we could streamline a tiny bit, inside of plant info, we don't even need a depth checker. We could call Q3 right away like so. Let's try, and then we should be done with this section. I want to restart the day 3 times, and both the plant and the resource have disappeared. Perfect. Really quick, I forgot one thing. If I restart the game once again, and I want to grow some corn, you can see in the panel container, the progress bars should cover the entire available space. At the moment, they only go up to the text. For that, inside of plant info, for the VBox container, we want to enable expand on the horizontal alignment. That should fix the entire thing. So now if I grow some corn, this is looking much better. And all the other stuff should also still work. Let's try. That looks good. Perfect. Now we are done. It is time to build the actual level. All we have to do for that is to place a whole bunch of trees and simple objects and make the game look nice. While we are doing that, I am also going to talk about performance, because Godot is giving you a lot of tools to monitor how well your game is doing. But step by step, first of all, back inside of the level, fundamentally, all that we have to do is to get trees and simple objects all throughout the scene. I suppose we can start with the tree and just move trees everywhere. This would be a good exercise. I want you to create a nice level. Pause the video now and work on it for a bit. Here we are back in the game, and I went a tiny bit ahead and created a whole bunch of trees and simple objects. Nothing fancy, I just duplicated things a whole bunch of times, and all of the simple objects are simply random, so you just get something else every single time. Those objects just don't matter that much, so I don't really care what we get. Let's try it inside of the game. This should still work just fine. And that looks pretty alright. Looks much better. That being said, there's one thing that I forgot about the trees. When you look at the Flash Sprite 2D, we have 2 H-frames. Those would give us a different kind of tree, and this should be randomized. When the tree is ready, I want to get the Flash Sprite 2D and set the frame either to 0 or to 1, which we have done before. I want to get an array with 0 and 1, and then pick random. That way, inside of the actual level, we're getting a bit more variation, which is quite nice. Looks good. Perfect. Now, obviously, for a real game, you would want to customize all of this a lot more, so you have an actual level that is fun to play, which I don't really care about because this is a tutorial. What I do, however, care about is the performance of the game, and that you can monitor. And for that, if I run the game and move the window up by just a bit, and then look at the debugger at the bottom without closing the game. In there, we have a whole bunch of tabs. The one that we care about right now is called monitors. I already have a couple of things selected, but if you simply tick some boxes, you get different kinds of monitors. And on the left side, there are a lot of things that you could be monitoring. And to understand them, let's talk about theory really quickly. The most basic thing that we have to cover is that the technical goal of a game is to draw as many frames as possible and to make the frames look good. This is measured in frames per second, or FPS. The more you have, the better your game is going to run. The minimum here is 30 frames per second, but the more you have, the better. To achieve that, you have to account for hardware limitations. There are 2 processors in your system, the CPU and the GPU, or the central processing unit and the graphics processing unit. The CPU covers general logic and things like pathfinding and physics, while the GPU covers all of the visuals. On top of that, both of them have their own memory. You have RAM for the CPU and video RAM for the GPU. Both of those are necessary so that both the CPU and the GPU have access to all of the assets in a really fast way. For lots of modern devices, RAM and VRAM are combined into one device. That doesn't change the logic that much. With that in mind, the usual limitation for a game is the GPU. Games are simply a visual medium, and if you have too many effects, the GPU might either not be able to calculate stuff fast enough or run out of memory. Both would be really bad. And this is the major thing that you have to look out for. Besides that, the CPU can also become a bottleneck. Especially if you're doing a lot of pathfinding or physics calculations, the CPU can struggle a lot. Back inside of the monitor, you can select a whole bunch of stuff in here, and the most important metric that you want to care about is FPS. At the moment, this one is at a very stable 30 frames per second, and that's the only thing that I want to look at the moment. This number is fundamentally all we care about. It should, at the very least, be 30 frames, and the higher, the better. But at the moment, you might be wondering, why is the frame rate so low? We have a very simple game, but it only runs at 30 frames per second. So we are already at the minimum. That actually isn't the case, because if you look at project settings, and then look for v-sync, this is by default enabled, and it limits your frame rate to the monitor refresh rate, so how fast your monitor can draw frames. In my case, that number is 30. In your case, it might be 60 or 120, or whatever your monitor refresh rate is. If you disable this number and rerun the game, then you are going to get very different numbers. If I now look at FPS, we are getting about 2000, which is a much better number. This is the actual frame rate, and besides that, if you look at process, this is how fast the process function runs. So at the moment, this is about every 2 milliseconds. You can also see physics process. This one is running even faster. The lower the number here, the better, whereas this number should be as large as possible. These three numbers are quite important, but once again, the most important one is frames per second. If this one goes too low, your game is going to struggle a lot. To get to this number, or at the very least to get it stable, you want to go a bit further down. Let me disable this one and look at memory, the number of objects in your game, and then video memory as well. At the moment, in terms of video memory, our game on the graphics card takes up 30 megabytes, which isn't very much. And inside of the CPU RAM under static, we have 80 megabytes, also a low number. Both of these would be totally fine. And by the way, if you look at video RAM, there you can see in real time what the major assets are inside of your game that you want to be aware of. So if you have a really large file in here that is maybe 50 megabytes for this kind of game, that would be a major red flag. Besides that, you get loads of other things that you can look at. For example, the number of objects inside of your game can sometimes be a useful hint. And if I disable all of these and you go a bit further down, inside of monitor, we have physics 2D, physics 3D, audio, navigation, and then pipeline. Along with navigation 2D and a few more other things, if you have a really complex game, like a city builder, where you have to do a ton of navigation, then these two tabs would become incredibly important. And if you have a physics-heavy game, then these two tabs would be super important. Depending on your game, you want to look at specific tabs and see what is important for your specific needs. And all of these numbers are basically a way to figure out where stuff is going wrong. In fact, let's break the game. Inside of the level script, we can work inside of the process function and then create a new object on every single frame. Let's say I want to create a new sprite by sprite2d.new. And this sprite is going to get a really large texture. which we can get from graphics. There we have the tile sets. Those are the largest ones. Let's say I want to load grass.png, which means I want to load grass.png. And finally, the entire thing I want to add to the scene via add child with the sprite. And this operation we are doing at the moment about 2000 times per second. If I now run the project and look at the debugger, first of all, the most obvious thing that you see inside of FPS, this number is much lower and it is dropping pretty fast. A very, very bad sign. On top of that, if you look at the memory, this is creeping up and up, which also is not a good sign. These two numbers would indicate that something is going wrong inside of our game, which it very obviously is. This kind of thing would be terrible. That being said, if you look at the video memory, this one is at a constant 30 megabytes. Because we are not loading anything new into the GPU, we simply keep on using the existing textures. So this number is unaffected, but these other two are doing very, very badly. So this is something we really want to avoid. But other than that, we now have a basic game that is running pretty well. And with that, we have finished the basic version. If you like it so far, check out the premium one on Patreon or on Udemy. You will get extra machines, hats, a weather system and a house, along with characters that sell you stuff. And you'd also support me make more of these videos.